Namaskar, good morning, good day, Sat Sri Akal, Assalamu alaikum, Warahmatullahi Wabarakatuh. Namaskar and Vanakkam to all those who are interested in this talk around the world, all my friends, ladies and gentlemen. This is Engineer Suraj Singh, International Professional Engineer, Chartered Engineer, speaking from Bharat, India. Bharat is one name and India is also one name. Just for clarification, it is Bharat, which means it is like Egypt means nation. It is same as we say our country, and this is statutory certification, statutory authority, constitutional, chartered engineer. It is chartered authority for rule of law in Bharat. And dear gentlemen, back to you once again with some more material related to management, engineering management, and other managements. And as according to daily, it's a rough paper I'm showing you. Maybe it's called rough, but it's original paper. Engineering management, project management, organization, FIDIC contracts, and concrete materials, solid, etc., etc. Whatever is possible to be shared with you is in your service. Sharing is important to everybody. Collection of information from books and from internet and from experience. All we talk is collection, collection, and collection. There is nothing original, nothing innovative, just informative for everybody. Information is important because this is time like that. And of course, July 31st, 2020, this day for everybody. End of this month, July, and August is starting tomorrow. August means year is 20, year is 20, and August is 8, 28. 28 number is coming, 28 number is coming, and 28 is coming and 27 is going today. 7 plus 20 month 27 is going. 28 is coming. System year is coming. This month shall be different, not like what's this is 7, and this will be very invisible, systematic system work of month, and we have to understand this way. Uh, Sometimes we say something, but we don't do something. SARS is there, some discussion only on SARS. Then, you know, God's Act, which is now engineering, management, systems, changes, organization, and challenges. Human thinking only and only resort, general, concrete, specifications, total, systems, quality, structured, soil, and FIDIC, all that. Daily something. But currently I am stressing on contracts and soil. Soil is first priority because soil is basics of foundation. Without soil, we can't even think of existence, and we can't think of life without soil. Soil is basis because on which we sit and stand, due to which we take our food. Soil is that element of our life. Cannot say no. And then, of course, water, of course, sun, and of course everything else that we do with we call constitution of human body, constitution of human body, which is dependent on dependent on these natural elements, not artificial elements. Natural elements like soil, number one, soil it is mitti, soil, water, pani, and Then air, hawa, and also fire, and either fire, agni, and asma, sky. These are mandatory materials gifted on, blessed on to all creatures on earth. In Hindi, we call, in our language, we call them Panchatattva, five elements. These are Panchatattva minimum, there are many more even this, which are not counting, like our soul. People do not know composition of soul. Some call it electromagnetic, some call it something else, Shakti and all that. Reality is unknown to us. But real element for existence is prayer is soul and this body composition of which is based on these five basic elements. If you understand these basic elements and if you understand power of soul, I think we can identify ourselves. I can identify what I am and you can identify what you are. Because objective of life is first your own identification and then only you can say you know someone. Life is not so easy as we consider. It's not just living, eating, drinking, and then sleeping. That is not life. That is routine and that is automatic. Because of survival, you have to live. This means you must eat something and you must respirate. You need food, you need clothing to cover your body. The clothing is already there in skin, yet we need further clothing. And you need some residence. That is basic natural requirement, irrespective of whose ownership is that. So roti, kapda and makan, हम जानते हैं. We know roti, kapda और makan, food, clothing and house, residence, very important. This is, you can say, why I'm explaining this, you know all this. This elementary requirement of life for human, for mankind, womankind, all. This is basic requirements. This cannot be denied to anybody. Everyone has right to eat, right to wear clothes, and right to have an area to sleep. And if you don't have this, then you are debarred of basic rights. You have money or you have money. That's not a requirement here. That's not a question here. Because money depends on opportunity. If you have got opportunity to make money, to earn money, to work, you'll get it. Some are born in money sea, some are born in ocean of money, and some are born in desert of money. Depends. If you are born in desert of money, it's not your fault. And those who are born in sea or ocean of money, this is not their achievement. This is basics of understanding, basics of organizational management. Because when you come here onto this planet, it's not your achievement. You are sent by someone. And if you're born in a rich family, it's not your achievement. And if you're born in a poor family where there's nothing, it's not your deficiency. You came only as human baby. It applies to all. You may be king or you may be chopper, nothing, cropper. You both are equal. Earth says you all are equal. There's no difference. But we do not understand that. We have we have come here just to identify each other. I am this and you are that. So there is no identification. Fact is that. There is no identification at all. Identification is your capability. That is independent capability, not your dependent capability. If you have someone is having capability because of family background, I don't consider that give number zero to that capability because that's not your capability. You have the supportive capability. You have got background, you have got support. So you can't claim that this is an achievement. I'm not critics of anybody, but fact remains capability is measured by your own efforts, not by supported efforts. You're having a wide support, that's not your capability. Management or organization has to be considered this way. If you're having relative supports, so you are doing nothing. These supports that are doing, not you. Same way. If you're achieving something in your life, it's because of your efforts, not because somebody gives you. Yes, people may support you. Everybody gets support from somewhere. I'm not calling that. Don't get support. but efforts, original efforts, not efforts on already available efforts, super efforts. No, no, I'm not from that. God wants something else everybody to do that we can't know. Here is what I'm thinking. You're also thinking differently. We think that world is our place. Yes, it is our place for some years. The day I enter to this station of Earth or airport of Earth, whatever you can say, this location of Earth, what day I enter and day I live, this is a fixed journey. This is not ownership. Remember, this is a seat. This is a seat for some years. You cannot own that more than that. You can't say leash. This is a kind of free lease for so many years. You are forced to come back after that. If this point we understand all, I think many problems would go away from everybody. Though we make families here, then extended families we make, everything we make for what? For imagination. We believe in this religion, this caste, that caste. For what? Imagination. I am talking about organization, management of engineering. You may be asking why I'm talking all this. No, I'm not talking all this. Because all these acts, all these issues are related to ourselves. And we have to introspect ourselves in engineering also what we do, where we get supports from. Engineering means you have to use resources. You have to procure resources. You have to use resources without idling, with of course with maintenance. You have to use material resources, you have to use human resources, you have to use equipment resources, you have to use technology resources, you have to use your own resources, you have to create resource, you have to do whatever is required for each and every item on activities of engineering. And engineering means do it, sample, know the meaning of engineering, think and do it. That's what, because we need resources all times for everything. When we need resources means, when we need resources means, we must get resources. So this resource I'm talking about society, I am talking about humanity, I am talking about nature, I am talking about earth. All this part is pertinent to engineering. All these are pertinent to engineering because we are going to use these resources which are blessed onto humanity by earth, Prithvi Mata, a part of universal system, solar system, part of universe. So we are supported by universe because we are supported by crops, by agriculture, by water bodies, by air body, air sphere, by sun and by sky. We all are supported. And maybe something else we do not know, we can't see. All this we can see, we can see air I mean to say, in whatever way. We can see soil, that's earth. We can see water bodies, we can see fire, sun, and we can see sky. All these are visible to our eyes and we observe them every day, every moment. So this means this is a resource. All these are resources. If you don't have sun, what shall happen you think of? If you don't air, what shall happen you think of? And same with the water body, what shall happen to us? If you don't have soil and earth, what shall happen to us? If you don't have sky, what shall happen to us? Though there's no skies, but we say skies may not fall. We say that. Means some relation is there because the skies means stars are there, universe is there, everything is there. So we are indirectly supported by all these sources. I should not say resources because these are original sources. If we can't understand that, if we conceive that, when you hypothetication of that, I can't say I'm an engineer, or somebody can't say I'm a doctor, or somebody can't say professor. If you can't think like that, think it doesn't think based on books. What book says? Book says very simple, very little. A book of 1,000 pages, 1,500 pages, 5 pages cannot tell you everything in life. You have to use this book here because this is a master book. This is a book which is the thickest of all and finest of all. That approach we should have. When I say engineering management, this is engineering management. Everything is engineering life, everything. Everything is engineering life. There's nothing which you cannot say engineering life. Indirectly, doctor is also an engineer. He engineers repairs. He engineers treatment. Doctor is, doctor deals with human body. Human body is also a machine. Doctor deals with mechanical part, not with soul part. There's a difference. That doctor is also imperfect because that doctor does not understand what is soul. That understand what are these elements. Blood is knows all the organic parts of body. Doctor treats them. Doctor cannot treat your soul. There is no one to treat your soul on earth. There is no one. People don't understand soul. And we forget the soul is force of body, just like we say in bending moment is there, your shear force, bending moment, deflection, and moment resistance, and earth force and wind actions, and this actions and that action. There are so many forces we apply, we calculate in our engineering structural analysis. There's some force in body also. How can I walk if I don't have energy? This will have energy. People say energy is soul. Maybe you think right, but energy is soul. You don't take food, you don't have energy. This energy is not related to soul. Energy is related to your food capacity, your water you drink, take coffee and tea and all that. Energy comes from that. So it's not nothing to do with soul. What about soul? You don't know. I don't know. What faith is there? Without soil, we can't live. So that is some electrical current provided by nature, electromagnetic current, or whatever term, whatever name you give to that. That's the you. We have to understand that point. When I'm talking of soil, certainly I'm talking water, and certainly I'm talking of air, and of course, certainly I'm talking of some chemicals, some minerals in that. That's what I'm saying, soil. And soil is basis of engineering because this soil, whatever soil is there, this is used in silicon chips. This is used in SIM cards. This is used in computers. This is used in buildings. This is used every year. This is foundation of foundation. This is foundation of foundation. You can say super foundation. We say we are designing a foundation to take load and transfer load to whom? To another foundation, that's soil foundation. We may call soil base, we may call soil layer, we may call in technical terms, whatever it is, but it's foundation, a foundation to receive foundation, foundation to help foundation which we design to stay there, durability and with consistency and this working capacity. That's what philosophy is. As an engineer, as a human being, I have to understand philosophy. Even dogs understand some philosophy, cat understands philosophy. To some extent, they understand, but their requirements are limited. They are required for the protection of their body from weather and also food, which we are. We think of it, but we are crazy. We are human being. We are very small part of universe. I think I am big. I think I am big in comparison to someone else. Otherwise, no. If you say we are 8 billion people on earth, I say he is the biggest one and he is biggest one. But with whom you are comparing? You are not comparing with God. You are comparing yourself. How 8 billion people? I am world richest person. I am world's best scientist. I am world's best doctor. I am world's best engineer. I am best teacher. I am novel laureate. I am this and that. With whom you are comparing? You are comparing yourself. You're not compared to cows or buffaloes or goats or sky or stars or someone. You are just compared to a limited quantity of limited population of 8 billion people. So do you think it's an award? No, it's not comparable. There's no comparison as such. This is comparison among idiots. We all 8 billion stupids and idiots there, including myself. I'm really stupid. It's just ridiculous statement. Don't take it otherwise. We compare with each other and find who is superior and who is inferior. In fact, we are nothing. Can we compare to that? That knows everything. That superpower knows everything. Past, present, future, design, engineering, medical, all arts, humanity, everything. Every subject that knows because that power designed and produced that subject. We are just learning through books. That power doesn't need book. And you also don't need books. If you start thinking, that's why I will say thinking is unit of future, thinking is unit of development. Don't take dictionary meaning of thinking. Thinking is something else. Thin and K, if you use thin K, go to narrowest path of something, go into atomic structure of something, go to into further down structure of that proton, electron, neutron, and further some electrons. You will be there in some real world unit of composition or constitution or something. That is what engineering unit lies in. When I say soil or some other material, it is not material, solid material. It is a unit of that atomic unit, you can say, is atomic structure that we talk of. That is basics. If you understand that, we can build a complete chain. You may call it DNA, you may call it whatever you can say. That we require to understand. And that is where engineering knowledge applies. In engineering, we have to learn this. This is important. This is important. Is a differential calculus, integral calculus. What is that? Just to know one thing down or one thing up, right? Something is for area, something is for land, something that's different application. But something go down, something go one step. That's mathematics. Oh, I have to raise this difference of this with this limit from this to this. This is the answer. If you say integral calculus says x to power 2 or divided by 2 or 1 differential. That's what it is. Simply saying that is that. So we have to think mathematically our life. Whole life is based on mathematics, and that is engineering. Mathematics is nothing but engineering. Engineering is mathematics, and mathematics is engineering, not subject mathematics, life mathematics. Engineering is full of mathematics. Sciences are full of mathematics, except medical. Medical is not full of mathematics. There's something called chemistry, biochemistry, microbiochemistry, and other educational system disciplines are dependent on this, are all dependent on that. So we engineers must find what's fundamental of engineering. What we are saying, that's advanced stage, but we have to know what's origin of engineering. Origin of engineering is your mind should be mathematical, your mind should be analytical, your mind should be descriptive, your mind should be logical, rational. This is what you are trained to do. I'm not talking of books. You can learn any number of books. Whatever number of books you can learn in the whole life, books. You can go on reading as many books you read, you will get that much higher interest because your mind is received into books. And if you do not use those books, you won't don't worry, then the mind will stay simple, silent, and sleeping. This is what my approach of towards engineering, because I don't take engineering as an exclusive profession to earn. No, engineering is not that. What we earn, that is different. Whatever salary or fee or you can say partnership you get in engineering, that is another point of view. That is financial point, because we have to survive financially. That's the only reason that people charge fees, charge salaries for that. That is different part, that's applicable with everybody, because you need food, you have to live, you need clothes. But that's not in, you can say, an objective of life, and not only for engineers, for everybody. Unfortunately, world is changing very fast. You see impact of COVID-19. Did you expect this? Nobody expected this. But this has come. Means this is in plan of God. Because there's a treatment, we say recovery plan. We say in our engineering, our engineering world that we have to do recovery, we have lost time, and we have to do recovery of that. We say that we have to do recovery. And we do it too. We do that recovery, and that's done for time lost or some other damages or something else. That's done to compensate time loss, or to upgrade quality, or to required mark, or to say what you can say time, quality, and cost, to manage how to reduce cost. All these are principles that we apply in engineering, but that is secondary. First, we have to apply principles on ourselves. When I say we have to think, that's our job. Yes, I think in engineering, for engineering, you think for your business, somebody thinks for some other job, somebody thinks for, how to do bad work, somebody thinks how to do good work, and somebody thinks how to cheat and how to serve people. Both, all kinds of people are there, all classes of people are there. And they do that. They do that. God does not stop anybody. This is duty of God. Okay, you do whatever you want to do. Whatever you do, you shall get accordingly. Do your job, and whatever you do, you shall get result accordingly. This is what God says according to holy books, and according to understanding also, not a question of holy book, because as you sow, so you reap. As you sow, so you reap. Whatever you sow, you get. Whatever you do, you get that. If say I walk from here to here, I change my location, right? If I start from here and reach here, I change my location. Means my result is I have changed my location, and then further I go some other place. I say I change another location. This is there some moment, maybe horizontal, maybe vertical, or maybe angle diagonally. That's the moment. Same is what we want to say. We have to understand this point in engineering. Engineering is not a discipline, in fact, that's only for purpose of definition. Engineering is not a profession, that's only for purpose of definition. Engineering is something else. We have to add value to earth, to lithosphere. Even we can add value to air, we can add value to water, we can add value to surface, we can add value to soil. That's what we say. We have to raise standards of living. What is the standard of living? From where it is come? Standards of living. It comes from nowhere. It comes because of your efforts. You have to work. What doesn't mean paid work or unpaid work? Work means service to earth, which is service to God. For which I came, you came. We may accept this point, we may not accept. Doesn't make a difference. You came here to do something that you have to do. If you do it very nice, it's good. You get benefit back. After all, there's no benefit at all, to be very frank. It's very small life. Somebody lives for 60 years, somebody 100 years, somebody 150 years, maximum 120 years. So, in that, how many years do you work? You know it very well. So, what benefit do you want? And why you want benefit? By chance you get money, you may say that is benefit, or you may get some higher certificate, that may be benefit, you think. You may get some Nobel Prize, for example, this benefit. What benefit is that? That's not benefit, that's what I'm saying. That's a relative benefit. You feel there's something. But question is, you have to raise question to yourself first. Don't think what others raise question. You are first question raiser to yourself. That is main point of examination, self-examination. You examine your life about your performance, about your achievements. Achievement means performance. Achievement doesn't mean final achievement. Achievement's contribution to earth. Not even contribution to humanity, contribution to earth. What you have done. Example, if I do something good for earth, which is at plus point, which is affirmative, so that earth is better, or people get better facility because of that, because material which I use is it only comes from earth. It doesn't come from somewhere else. It is supported by sky, it's supported by air, supported by sun. That is support. But material part comes from earth. Elemental parts. Metal you may take, water you may take, soil you may take, everything you may take. Everything comes from earth or lithosphere. When I say lithosphere, this means solid part of earth. And when I say earth, earth means air sphere plus solid part of earth equal to earth, equal to lithosphere plus aerosphere is. I have defined it somewhere in other talks. You can refer to that. I'm fortunate that I am able to serve you in this regard. That's my, you can say, my support from God, my good luck, you can say. God gave me these blessings that I can share this information with support of God to you, with you. I consider myself fortunate enough that God is giving me energy, God is giving me willpower, God is giving me time to get up early morning, prepare for this, and talk to you. You may accept, you may not participate. That's your choice. But after all, something is to be done. So I'm trying to I'm trying to disseminate something which is in my mind. Maybe I'm not right. You can question me. If I'm wrong, I will say, okay, I apologize for that. I will amend my act. That's process. That's follow up. But that's what minimum have to do. I want to get whatever small information, very small information I have about engineering in field as well as in education or in designs or where in other sub disciplines of engineering like safety, health and environment and economics and of course planning, scheduling or quality methods or whatever else it is, whatever information I am just having that information, whatever I could add because of so many years of experience, I can't digest that because even if digest, what shall I do with that? Because one day I am going, I have to go, so that shall go with me. So I just want to share with you so that it remains here and somebody else may get benefit of this, not to waste time because I wasted a lot of time in learning all this. Learning is not easy. You think if you pass out from university, you are okay. No, you are not okay. No one is okay. I have seen many doctors. Even after having top degrees in medical, they are not able to treat patients. They are not able to know everything. And because they pass, they did not study. There's a difference. You pass out or you study. Two are different. Passing is one part, learning is another part. I like it. Somebody taught me this. Passing examination or passing one degree, whatever degree, any degree, it's the highest degree, does not mean anything if you don't learn. Learning, we call them institutions of learning, not of education. If I say somebody passes engineering is okay, but learning is different. Passing and learning are not same. Learning has no limit, passing has limit. Passing as a barricade. Okay, you pass a school barricaded, you are graduated, you pass a school, you are graduate of school. Okay, you pass under degree, you are graduate of that, you are postgraduate of that, you are doctor of that. There's a limit. You can't do more than that. You will be taught only that much in a university, only on papers, not in real life. It's a film, just like film is imaginary. Real life is different. Schooling is a film. You are taught this, you like it or don't like it, you pass and that's it. Do not take it as consistently. No education is consistent and competent. No education can assure you are fit. Remember, no education involved from whatever institution you pass. It cannot guarantee that you can work. It cannot guarantee. This is that sure. No certificate can guarantee that you are a competent person, though that's called a certificate competency, but that doesn't guarantee competency. You have to prove it. That's what is the main point. You have to prove it. If you prove it, fine, very good. If you can't prove it, then it's no use. Even if you have biggest certificate of world, top certificate of world, and if you're not able to dispose of your responsibility according to that certificate, that certificate is piece of paper, nothing else. Put on your wall and show it that this way. That's why I say learning. Learning means learning means you have to apply your knowledge correctly, rightly, and you also learn from that application in whatever field it is: science, engineering, arts, humanities, or you can say accounts field, political field, whatever field in life you are involved in. Forget what's happening in world. Forget what's happening in politics, what's happening in COVID, what's happening somewhere else. This all phases says come and go, but humanity stands. These are phases, these will come and go, so many means. They are all teachers of humanity. They have come to teach you silently. We have to understand that. And we can understand that's our capability. If we can't understand, that's not our capability. So, my dear gentle people, my dear friends, I am little different in having my contemplation. And that's what I want to share with you. Do not go to references, go to origin of problem. Origin of problem. I am finding these days COVID-19. It's I'm just this because this is life. It's not because I'm talking of COVID, I am interested in that. It is an impact in life of whole world. There is no place untouched by, remaining untouched by COVID-19. See power of this COVID-19, power of this corona, this force. I call it a force. I don't call it, a virus or a disease. I call it application or impact of force nature has sent it. Take it this way: it's a force, invisible force. Doctors call it whatever, scientists may call it whatever, but as a you can say layman or lay person, or you can say as a illiterate person, you may say illiterate person, I may call it a force. Force, 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 which may look to someone far or which may look to someone rare, because I deal with force. I am an engineer, and every engineer deals with force all the time. One works in design, or works on site, works somewhere else. Force always remains in mind. On design, we say so many forces apply on this structure, very, very kind of forces. And in what we say workforce, that's another force. Workforce, other forces, wind force, thunderstorm, everywhere force, army force, armed forces, everywhere is force. There's no force. Country itself is a force. Humanity itself is a force. When I walk, I'm applying force. Right or not right? Do you know that? When we walk, what we do? We apply workforce. How work is done? Yes, work is done. This is engineering, this is mathematics, this is physics. When you walk, what happens? Your weight is down, your body weight, whatever kilogram is down. But you say, I'm walking. How you're walking? Who is forcing you to walk? Who is there to apply? Which machine you're using? But you're walking. This means there is some internal force which you are using, is energy or whatever. You're walking. So there's a force. Everywhere there's a force. And think of that. 8 billion people are applying force on earth. So many machines are there applying force on earth. As so many forces on this earth are applied without removal. These forces continue forever. It may be stationary form or dynamic form or whatever form these forces do. They are working all time. They do not go somewhere else, and earth is taking them, earth is digesting them, disseminating them into its body. What shall we call it? What kind of engineering is that? Right? That's what I say. I'm talking plainly like kids. I'm thinking I'm kids now. I'm talking like that. Kids of education, kids of profession, kids of mission. Currently, I'm just trying to let you understand what should be done in life. See, making money or whatever that's different part. I'm not going into that. Money, yes, it's useful for life. It's true. Nobody can deny this fact. Money is a must. Money is a must, but there are many more musts higher than money, a value of which are higher than money. We should understand that point. One must is not adequate in life. Life have many musts. Problem is we are not satisfied with anything. If I have education, I say I want job. If you have job, I want better job. If you have better job, I want to do business. Your must is never stationary. Your must is also changing. All time it changes. Your destiny changes. Your greed changes. Your avarice takes you to somewhere else. And that's where we can't concentrate. Concentration is very important in life. Concentration doesn't mean yoga. No, I'm not talking about that. Yoga is concentration, but that is for something else. Everybody is yogic. Yogic doesn't mean do exercises and think down with your sitting position and say, I am doing this yoga and that yoga. No, I'm not talking of that yoga. I am talking of mental yoga. When you use your mind, that is biggest yoga in this world. There is no other yoga that can overrule this yoga. Means once you are in yoga of mind, you are at God doorstep. Mind is that, you can say, a key. Automatic transmission, that automatic transmission switch. Mind is automatic transmission switch to God. This is definition of mind. When we use some generator, automatic generator, and connect it in some electrical line, and there's no power, this cell automatic work, automatic switch, automatic transformer switch. You say it automatic. It starts working itself when there's power cut, and it stops itself when there is no power comes in. So it is automatic switch. It is. It's a very fraction of a moment design in that. That's where it is. This that your switch. Your switch is biggest control of life. Without this, you can't do anything. So, can you understand this? Can you understand this? We depend upon mobile. Very small SIM is there. Very small SIM, and it gives you so much information. It connects us to others, and we say, I am on this line. Means a small chip or with a card, you can talk to people, you can send messages, you can watch videos, download whatever you want to that. That is very small SIM card, we call it simultaneous identification module, and you call it that. But even in computer system, you call it a system. System of what? System of some circuit that is linked to your card and hardware. That is system. But what is hardware? What is after hard disk? You have name of Silicon Valley. What is that? Did you ever think of that? What is silicon? What is silicon after all? Can you think of that? Yes, you should think what is silicon. Silicon is nothing but mineral. It's nothing. It's a mineral. Mineral of within. Where's mineral? Mineral is soil. Mineral is your body. Your body is also soil. Your body itself is a soil, having many constituents in that, many compositions. Blood is there. That's also soil. Your skin is also soil. Your flesh is soil. Your bones are soil. Tell me what is there that's not soil? Having different densities, different connections, different structures we have in our body. It's all atomic, all electronic, nothing else. And self working. It works self from one sperm to full body. Think of that. It's not something automatic. That is automatic. We should not boast that we have automized everything. You have not automized anything. In fact, you have not automized anything. You talk of 4G or 5G, or you talk of Internet of Things, or you talk of whatever. You have not done any automation till now. Your body itself is an evidence that it's automatic. You only take food, that's it. You are doing nothing else. And your body works for how many years you live, without any lapse, without any stop, it works. So what you call it? Is it not automation? It's super automation. There's no generator required here. This is what we understand. We are, the problem is when we have something, we never consider that again. If I have good money with me, good bank balance, I will stop thinking about my problems, but start thinking how to multiply my money. How to multiply money. That comes into my mind. When I am a good having education, or I'm good in education, I must get professional education. If I get professional education, I get more and more and more. Getting does not stop. Will to get does not stop. Will to get something relative does not stop. I am saying relative because we don't get original. We get only in reference to something. Well, I'm not here to explain all this like gurus. I'm not guru. I'm not. I'm just trying to scientifically tell something, and because we have to control ourselves. It's true that people are not sincere these days. They are not disciplined. Society is not disciplined. I think this generation and also I think previous generation after this, they are not well organized whole over world. I see if you see conduct of people, conduct by people all over world, particularly youth. Youth, I'm not blaming seniors, because they cannot do that. Youth, they are not disciplined anymore. I think if you do 50 to 100 is a bad. They were disciplined people. They organized people, though there was no education in those days. They were not very well formally educated, but they were socially educated. They were by civilization advocate. I mean, educated. They were educated virtually. I'm to say they were educated by experience, by act, not by theory. And we are educated by theory. That's why I think we are in theory only. We don't understand what is practical. So world is changing in such a way that this is deteriorating itself. There's a detrimental effect on world. This we are finding very openly. There's no secret to that. You can consider England, America, or Europe, or China, or our country, or where you go, you'll find complete disturbance in the homogeneity of society. And people have become crazy. No tolerance in them, no wait time in them, no patience in them. Means they can't tolerate, they can digest. If some discomfort comes to them, they cannot tolerate that. They are used to their own liberty, own will. It's not in their hands, otherwise they will take wear out all clothes and walk on road. This can happen. And this happened also somewhere. Well, this is personal life, how you live, but you can live only to yourself, not exposed to public. But this society has changed to major extent. If you, for example, I'm just going to give an example. If you can't wear a mask, if you hate it or you resist that, well, what can you do in life? Just tell me. If somebody says use mask for your own protection, somebody says, because I'm not going to get something you use protection, I have to take my care, you have to take your care. And if you just fight on that, just dispute on that, where do you stand? Where do you stand? Tell me. Only for this small item. This gives you protection. This is a precautionary measure. This doesn't guarantee anything. It's a precautionary measure. If you can't take precautionary measure in life, how shall you fight with hazards? Hazards, do you know hazards? We call in our engineering safety system JHA, Job Hazard Analysis. JHA, Job Hazards Analysis. We do that in engineering, safety department, safety, health safety and environment and ergonomics. This job job hard no job hazard analysis we call them. We analyze every activity, whatever in engineering we do, in construction or mechanical or electrical or whichever work we do, there is always some hazard associated with that activity. That hazard, HAZARD, you know spelling of that. I'm just telling because younger people don't know spelling these days. They don't write, they don't read, so spellings they miss. And I'm finding 70% mistakes in whatever writings these people do on internet or somewhere else. But what to do? These people of that nature now you can't change them. They can't change themselves until they are beaten in life. Beaten, I'm saying their acts, not physically beaten, beaten in work, beaten in callings. So job hazard analysis, we take them very seriously. We know before what job we are going to do, what job, what actions are required in that, what method is there, and in that consideration, on that basis, where we can find problems, where we can find something. If we do it after we are beaten, after we are applied with hazard, then this is not sensible. Then there's no intelligent work. This is a work of foolish people where you are beaten and then they know. If you can foresee that, this can be problem. This means we can resort to precautionary measures. But for that you have to think. Again, think comes here. THINK. You have to think for that. You have to imagine if it happens, this can be a result, or if that happens, that can be consequences. You have to collect that this way in your mind. Don't ask anybody else. Don't ask someone else. You know that because you're a qualified person, you're educated one, you're experienced one. You must have, even if you don't have done that, you can think how it can be done. What effect can it be there? If you write four or five points of that, you can solve that. And when you solve that, you shall come into more points, more knowledge, and more, so more points will come to you, project to you, and you have to solve them as well. So if you study that pre stage of activity, this is that hazard won't come to you. Hazard will go. Hazard means unexpected problem, unexpected threat, unexpected emergency, unexpected problem, exposure to that, which you never expected or you could not foresee, and you meet that. So how to handle that? If you have not taken any precautionary measure, it shall be difficult to handle that. And if you have thought of that without that, due to experience or due to your extraordinary knowledge you earned, you can fight with that. Fight means precautionary measure, avoid that. Fight doesn't mean go and stand, start wrestling or freestyle. I'm not talking that. Means hazard, how to handle hazards. When you handle them, you will find some more time saving and cost saving and quality increase, quality enhancement. These 3 points, we consider these three basics on management triangle or scheme triangle or programming triangle or whatever you can say. When we consider something, we have to consider time, we have to consider cost, and we have to consider quality, and of course, so many more substances are there to consider. But these are primary, some basics one. So when we understand this can cause this problem, and we know this problem can be there. If we expect there's a fire can happen here, it can break, fire can apply, your fire can break here, and we have to provide something so that we know before fire has started, we can extinguish that, or we have to take some other measures there. We do that. So life itself is a fire. Problems are fire. We have to show. We have to extinguish them. We have to extinguish them. Or we have to fire itself. Fire. Extinguish fire. It's very simple statement I'm making. So why I'm saying hazard? Now there is hazard in the whole world. We know COVID-19 is nothing but super hazard. Like nobody thought of this 1 year back, 6 months back. Nobody anticipated that this can happen, and no one was ready. So this has acted as art. If we anticipated such hazards before, we could take care. We could be prepared. But now still we are not prepared because we do not know what is this hazard actually. We know this is impact of hazard, but we do not know real hazard. What hazard is that? Despite we have thousand scientists and all over the world, highly profiled scientists, they haven't reached any conclusion yet. They have not reached any conclusion how to fight with this. So this means we are short in education, we are short in mental analysis, we can't imagine, we can't think. Imagination and thinking are very important. I'm not saying dreaming, don't dream. Imagine. Imagine and dream are different words. This is a dream, but this is calculated dream. When you imagine something, this is calculated dream. Vision is also imagination because neither you are sleeping, not you are awakened, and we are looking some visions into that. You are searching into that. That's what I'm talking. What's happening in England? What's happening in Europe? What's happening in all America? And what's happening in our country is super hazard. Super hazard. We were not ready. Public was not ready. Forget political leaders. I'm not talking about. Public was not ready. We are not still ready. We don't trust anything. We argue for nothing. As if I don't know why somebody is asking me to wear mask. Question comes into my mind. Who are you to ask me use mask? I don't know how to use mask. Yes, you can say I don't know how to use mask. And you can give explanation also. But you forget. This is hazard. This is hazard. Don't you understand this? You have to understand that. Don't be friend to hazard. Don't make hazard your guest. Fire cannot be your guest. Earthquake cannot be your guest. Flood cannot be your guest. Landslide cannot be your guest. Lightning cannot be your guest. You have to be serious. It's not your personality that is the question here. It's not in person, I am person. It's all masses. Everybody is not intelligent in this affair. Everybody cannot understand everything. All category of mind level people are there in this world. There are some people who can say something. But you have to understand. They don't understand. They take it, oh, why are you asking me this? Nobody is asking anybody. If I ask you wear mask, it doesn't mean I am asking you. I am asking you wear mask because I am thinking of others. I am thinking myself. I'm not thinking of yours. I am not thinking. Yes, indirectly I am thinking of yours. Indirectly, because you have to wear mask for your precaution first, for your safety first, and then for safety of others. It is public safety. Who are you to violate that? Yes, you can say, I don't care. Let Corona come to me. You can say, yes, it can come to you. Say it comes to you. Let us say it comes to you. Then what do you do? What shall you do? You get, I'll go to isolation. Okay, that is procedure. But can you take out Corona from your body? My question is that. If you are infected by Corona, can you remove this from your body? A question. It's a question. Hazard related question. Risk is involved. I'm not doctor, I'm not scientist. Common understanding in safety says if something goes into my body and can come out by some medicine or by some injection, then no problem, that's not a hazard. Okay, it comes. First, I have to take precautions, and by chance, I'm accidental there. I meet that accident, it enters my body. I have to take some injection so that it goes out and dies. But that is not stage now. That stage doesn't come now, hasn't come now. We're all scared. We have not learned about this disease yet. What is symptom? Symptoms, okay, what's cause of this disease? No one knows. This disease is still full of secrecy. This COVID-19, corona, infectious disease is still secret. This is a virus, coronavirus. They call it virus, but they don't define what virus is. They don't define. I asked one senior doctor, what is virus actually? Tell me, it's a living being or it's not living being. The doctor says it's living being. All viruses are living being. Oh, so it's living being that's powerful. It's not simply material. Or it's not simply some mineral. It's living being. And if it's living being cannot be produced by human, can be produced by God only. Human can produce mechanism, or he can produce some material. Human can do that. Human cannot make soul. And without soil, I mean to say soul, not soil, soul. Without soul, there can be no living being. This means if it's living being, it's soul. Soul, it's just think of. If that size of this particle is 0.0000024, something like that. That size of this body, what is size of particle of that? What size of atom in that? In Atma, but we should understand this point. We are logical people, we understand mathematics. We understand sciences, we understand physics, chemistry, we understand engineering, we understand everything. So we should understand this also. Hazard is hazard. And if you say ask something, do this for protection from this hazard, then this is not against you. This is not against you. Because one should be responsible. You are responsible towards others, not towards others. You can take, you say, okay, let it come to me. How shall you stop from you to infect others? Do you have some solution for that? There is why I use mask. So I that's why I'm saying use mask now. If you want to use mask that time, when you also use on your own, I use mask so it doesn't go to other one. So what's the problem here? I say use it now so that it doesn't come to you. If it doesn't come to you, it will go to the other one. So simple. What is science in this? What is engineering in this? No science, no engineering. This simple mechanism, precautionary measure. Savdhan, होशियार, बच के रहिए. What's wrong with that? All people in the world are mad. All I can't blame this country alone. America is getting fooled. Britons are getting fooled. Europeans are getting only for mask. This mask in France, this driver was killed just for mask issue. See, stupidity of these people. Those people wanted to board buses, drivers say, no, go and use mask, and these people have started crossing them, and this driver lost his life because somebody, that person was responsible, that driver asked you use mask for your safety, for other safety, and you killed that driver. Is that sensible? As to what level of idiocy we have got? Are we really human beings? Are we left human beings? We are no more left human beings. We are mad society now. Previously, we mentioned every country, oh, America, maybe this and France, maybe this and England, maybe what we know now. What are they? Means imagination was different knowledge. We imagine for that. But now, no, we do not imagine anything. We think facts. Not responsible all English people, not responsible Americans, not responsible Europeans, not responsible our people, not responsible Chinese people, no responsibility anywhere in the world. Even the Arab is imposing fines because people are not accepting. 3,000 drams fine in UAE. Why? Because people do not accept. So there is no other way to impose fine, that's all. People really crazy. So I don't know why I am talking about engineering. If you don't accept this problem, solve, how shall you solve engineering problems? Engineering are major problems. Major problems. I'm not finding industrialists are responsible. I'm not finding factory owners are responsible. I'm not finding political leaders are responsible. I'm not finding engineering community responsible. I'm not finding any part responsible. All have withdrawn from this problem. They cannot handle. They talk of skies. They can't handle this. They can't handle Mars. They can't handle living. They can talk of skies. I can bring sun to. I can go to Mars. I can go to this. They can't help. How to help people to save? They have safety. No, this is nothing. This is safety only. Safety, health, and environment we call engineering field subject. SHE. This is nothing. When you do not know anything, you can only take production only, and I want to have protection. That's it. It's not I say I want. When I say I mean to say whole world want that. Why fight? Why be reject? This is not time for celebration. COVID-19 time is not for celebration. This is time to get yourself safe first. No need of marriage in this time. No need of celebration in this time. No need of anything in this time. Only to first save yourself. Governments don't understand. Leaders don't understand because they are fools. All are fools. World has become fool. Trump-like person is fool and idiot is. Our person is idiot. For the English person is idiot. He was in hospital for so many days because of this disease only, but he could not understand. He could not learn a single lesson till now. He came back from that point, but he could not learn even going to that point. What a shame. These people cannot learn. France cannot learn, Italy cannot learn, China cannot learn, we cannot learn. What for our leaders are here? They should all be kicked out, I should say, and some intelligent persons be placed in their positions because they deserve such treatment. This is also part of social engineering. We need suitable people for a job. These are suitable people. They just want seats only, votes only, nothing else. No intelligence application. Already 150,000 people have lost lives in USA. They are saying 150,000 official news, and how many it is unofficial, I can't say. Multiply by 5 or multiply by 10, you think yourself. If they say 150,000 and they say 3%, others are recovered, they say let's say 3% deaths. What does it mean? They say 44, I to say, yeah, 4.4 million, 44 lakhs, 4.4 million or 4.5 million people infected. So about 3% or say 3.5%, deaths are there. They say only 3.5% deaths. You think it's a joke? Only this. Others are recoveries. How? What does recovery mean? Abuse of word. It's not recovery. It's returning back. It's not recovery. Recovery means complete treatment from that disease. Have you treated those patients? When you don't know what is disease, what is its root cause, then how can you treat? It's just stupefy whole public. Recovery, recovery, recovery. Where is recovery? You are not recovering. Disease is inside. Virus is inside. It's clubbed in inside. It's embedded inside. It can come out anytime future. It's not recovery. You are a house now for that virus. A person who is called, who said is recovered, actually that person is a house for this virus. One day that shall certainly impact this body. Well, you may say I have gone to something else. Coming back to subject, that is soil engineering and management. Actually, this is part of management I was talking to you. Engineering management. This is all I call engineering management. It doesn't matter civil engineering. It's social engineering. It's world engineering. It's I know dealing engineering or whatever you call it. It is that. As human being, I thought, I think, and I share with you. I don't remember after 1 minute I told you, but instant thinking, improvising is like same thing. You could instantly think and answer, or you improvise on something, it's no different. So, my dear friends, I think first responsibility in life is that one should be responsible. I can't expect baby to be responsible. I mean, the people who are expected to be responsible should be responsible. But unfortunately, there's a lacuna in that, and people are not. Well, I was talking of soil engineering, which as an engineer I consider a very important subject, irrespective of whatever education background you have. I don't care for that because doesn't wait for educational background. It works. It's there everywhere and it works. It's there in below water or on in continental ocean. It doesn't care for everybody. It works. So soil is very much important for every person, every engineer, every supervisor, every you can say person who has to resort to decisions, who has to think about something, how to handle this on site, and even foreman supervisor are must be, or can say must be, having some information about soil. And therefore I started this talk of soil. Actually, soil was not my program before, but when I tried to understand, tried to talk, interact with people, I thought that there is some misunderstanding about materials. People have some misunderstanding certainly about materials, about engineering. That's the conception that soil is not a part of civil engineering. I disagree with that. Very much disagree. It's not question of engineering and not engineering. Soil is very much part of life. It's very much part of life, and without soil, we can't survive. So it doesn't relate to some discipline. It's very common. For a farmer, soil is very important, because without soil, farmer cannot grow crops for you, cannot do anything for you. So for existence of world, soil is important. Forget development, soil is still required. Even if there is no development, soil is required. For food required, it's required for that. And everybody can be a farmer. It's not that you can't be a farmer. You can be. But no, I'm not saying that. Now, point is soil engineering, and as I discussed before, there are many varieties of soils, but important from engineering viewpoint are only few soils which we accept, we regard, we use on our engineering activities. We disregard only those soils which are not good for not good in strength. And when say strength, soil is a material, it's not immaterial. We should take soil as very important material, because it is there, it shall remain there wherever it is, and wherever we leave it, we prepare and leave it, it shall remain there forever, below foundation or below road or below whatever structure you do, flyover, wherever you do it, it will stay there, serve it. That point of view we have to consider. And because soil is unknown to all, it's really a very different situation that if engineers say that, means engineers fundamental work is to know soil. Even if you did not study by say for some by to some reason, you can study it now. That's no problem. That, and study doesn't mean you have to do mastery or doctorate in that. Real understanding, physical understanding, and an understanding that can take you to making some decisions, that stage is required to be known. I'm not going to say do X-ray on that or diffraction or no need of that. That's something else. But we have to understand, just like we understand each other. We have to understand soil also. That's very important point. It's important here. I'm just stretching myself. Soil is to be understood from that viewpoint, and that's the reason that I'm involving my time. This time, your time actually is not my time. I just want to use this time for augmenting, for enhancing, for sharing some knowledge. I'm not expert. Some knowledge, a little knowledge, so that you may take a little from that little. Otherwise, you may suffer. These days, all use net, all use internet, and they write so much. There is questions, and they write on that. I am structural engineer. I am civil engineer. I don't know all that people write. I have passed MTech, 2 years experience. I have passed this. I am doing this. and they are all engineers in right thing. And they raise very, very small issues which should not be raised if they are really qualified. If you are a qualified engineering graduate, or you're postgraduate, or you're PhD even, or whatever you are engineer ultimately. You may be a PhD, you may be a master's, or whatever, you may be 70 years old person, you are engineer first, then something else. Because ultimately requirement is engineering, and that knowledge is important. And if being that you can't decide about problems, you are doing some side work which you are supposed to do, whatever qualification you have, you cannot isolate yourself in name of designs or in name of planning. And if you do that, you make losses to yourself. Means you can't understand anything if you don't experience site work. This is my conception. If you don't work at site, I'm not saying whole life. If some period of life you don't work on sites, you can't understand activities. That's also a fact. To understand activities, you must be used to site. You must be there for some duration of your career. Otherwise, you can't decide. You can't decide. A decision doesn't mean because you are aged you can decide. No, I'm not saying that. Age is in work, not in age by physique. Say you are having, suppose somebody has 10 years experiences, I am that year. Yes, you are 10 years experience, but how many years experience do you have on real work, in field, in front? And if you don't have any experience in that, then you have no experience, I would say. You have only theoretical experience. There can be any problem. There can be whatever problem on sites. I have seen many problems. And problems are there because problems are problems. You have to solve them. I have seen you if you can't identify even soil, what sort of soil it is by just leaving at that by wish just see at soil, collect some handful or fistful quantity and see what's if you can't even identify this sandy soil or this is clay or this is silt or this is something else, then what sort of experience you have? You're excavating, you don't know what soil structure it is, and you're going excavating. This may be a soil which can't stand. This may be a soil which is angle of repose how much. All this information comes from practical experience, not from your books. Books explain everything, but you cannot understand them without going to work on site. There can be any damn situation on site which you have to resolve. And if you have experienced that, you can sue, or otherwise you go on asking this person, that person, this person, that person. So then what for you are here? If you can't understand basics of soil, basics of, I'm calling basics of soil. I'm not saying the expert on that, but basics of soil means you can't then choose what machine you need, or how can you plan this excavation, how can you start this, is formation level of that soil good enough for your project, can you rely on that, or whatever report about soil you are having, is that a reliable report, is report that is valid for that. These questions must be answered, and you have to answer this question, not someone else. You are in charge, or your site engineer, or your project engineer, or your structural engineer even. You have to answer that. And if you can't answer that, you can't solve that, then what you are there? Nothing. If you demand about others, somebody will come and I'll consult him. Then consultants is only consultants. It's no responsibility. Consultants are consultants. They are not volunteers. They won't volunteer you until they execute that, or they design that, or they sign that. Responsibility comes only then, not otherwise. So my point of view is I respect civil engineering, I respect engineers, but I don't respect those who boast only. I don't respect those. First of all, I never claim that I'm a structural engineer. I should not claim, I don't like it. Because why should I confine myself to structures only? My point is that I do not confine my knowledge to structures, no. Engineering is wide, my field is wide. Why should I say only structure? I'm not structure. I'm okay, you are bigger, so you remain structure. Yes. I know structures, yes, I can do that. Maybe I'm not that good as you are. Maybe I'm not knowledgeable as you are. I'm very small, maybe 5% of what you know, or 10, 2%, or 0%, but I don't claim that I'm that. Because claim something which you are not doesn't mean anything. We should know every aspect of our field. Means you cannot for everything say I will consult this and consult that. Why should you consult for everything? Are you not educated? Did you not apply your mind for something? Okay, you do not know something, for example, you do know you have no solution of something, or you don't know something is new for you, then that's different case. Then you have to learn that first. But if something comes to you within a variety of forms, you can't do that. Can't understand that. This means there is some error in your approach. That error is rectified. No prestigious, no egoistic issue. Don't say that I am this and I'm that. That statement I don't like. If you are engineer, means you are engineer, and that's it. I respect word engineer and not other words. Of course, my education is civil engineering. I'm a very small person. I'm not doctor. I'm not masters. Okay, you be doctor, you be master. Congratulations to you. You enjoy your status. But I am very small person. Very small engineer I am. That's it. Why call big? No, I'm not big. But I care. That's the difference. You are big, but you're not caring. So what's the use? Tell me one question to every engineer. There are millions of engineers, particularly civil engineers, who are responsible for quality. Mechanical engineers are not responsible for quality in buildings, in structures. Electrical engineers are responsible only for their part of quality. And regarding mechanical machines come from industries, already factories. They don't manufacture anything. They just design and procure machines. Even some quality is only in, say, centralized AC, or some lift they install. Lift is also manufactured in factory. Similarly, structural steel, some in some part of world mechanical engineers deal with that, in some part of our civil engineers deal with. So these are some matters which are not in your hand, beyond your control in quality. You don't have command on that quality. You can complain only, but you can't control, because that's not your production. That's beyond your controls. So you are not in that class that you can be called. You are responsible. You can't be labeled responsible. Mechanical and electrical. Yes, it's systems you are responsible for, not for manufacturing quality. Here I say to all engineers, I request to all engineers that despite your education, despite your experience, whatever you have, you are responsible for quality. I don't care what judges say, what politicians say, what do you say, that is important. That's more important. What you have done for quality in your life, that's my question. I have seen many books, of course, not professionally related books, professional authors, other authors, academic authors. I've never found anywhere in those books certain solutions of field. I haven't found anything. There are books by very big authors, very great authors, highly qualified authors, but only references. Only references. If you read a book and at the end you'll find 50, 40, 60, 30 references in that. So those books are references books, not real books. I have not come across any book so far that tells you have to achieve quality, and this is method to achieve quality, because in examinations too such questions may not be raised, because they themselves do not know answers to these questions. Those questions are examination question writers. They are not exposed to those field experience, so it's not their fault as well. responsibility of quality achievement, whose it is? You cannot blame site engineer. No, you can't blame. Can't blame them. Whatever is trained, whatever training that person has, and that doesn't include how to achieve quality. That person doesn't have that training. So if that person doesn't have, you can't expect foremen, supervisors, or other people, workers, to know that until they are trained. Who shall train them? There is no trainers because we do not know quality. I can't say we do not know 100%. We do not know thorough quality. So is my point. This point is very important, and I also don't claim that I know quality, but something, we try, but people don't try, unfortunately. Quality of concrete, we talk a lot. Quality of concrete blocks, quality of plastic rendering, quality of many other activities talk. Quality of soil, we never talk. We never talk. Quality of soil. What quality do you think soil is? Soil is soil. Yes, soil is soil. Soil is soil, it's right. But what soil it is? This soil is going to accept your work. It has to accept your work or it has to reject your work. It won't tell you that, but it will infect your work. To be very frank. It will infect if corona infects you. It doesn't tell you who are you or who it is. It just infects you. So soil is same. It's a kind of the injuring corona it is, injuring COVID it is, soil. And I don't know why people run away from this. This is very simple. I not even subject you can say. I can't even consider soil as subject. It's only material because this subject hasn't developed yet. Soil as a subject hasn't developed yet. It is just information. Not even 100 years it is gone. Means it has to develop. Whatever information do we have by from sites or from some references, whatever we have, whatever small literature we have, or whatever machines are used to know its background, the structure we have very little knowledge about soil. We have to learn more and more on this. We have a lot of knowledge about in concrete technology. We have knowledge about stress analysis. We have knowledge about analysis of structures. We have knowledge about design of foundations without soil consideration. Sea fund without considerations of soil. We design foundations sometimes, at least we assume this one. Based on experience, we can say such. What experience you are talking? Every soil is different. Composition of soil is different. There's no uniformity in soil all over. It's heterogeneous sometimes. It is having different percentages of various materials, various kinds of soils in that. So we have to be very smart in that. We have to, if books cannot tell us, we have to understand ourselves. We have to find that. Now some literature is available due to internet, we can find that. I was talking about soil yesterday. I talked before about I started something of soil, and yesterday I think I opened a file now. Just what talked yesterday was it's about file that was a month. Wait a minute, month not month. This was yeah. This was this file we talked, and it was let me open it please. It is you know that was don't guess it. It's written on that very interesting one. It's written on this. I shared this file with you actually. I have shared this file with you already. This is thermal resistivity. Don't guess and measure. This is that file. I this is already there on share. It's already what is it, screen share URL on Facebook. there, and I've taken two more files on video. I can say screen share. Yesterday I recorded two, and that is about Montmore Illonite soil mineral, Montmore Illonite mineral, that I've already recorded, and that URL is available in this video's top text. You can see there. There are three URLs in addition to video URL. This one is about this file, that is thermal resistivity, and other two URLs are about Montmore Illinois. I shall keep more URL there when I record. I mean, record is direct live. It is. You cannot say it's record. It's live record, because facilities there in videos that I thought that I can fix that. I can record that along live regular video. I tried that, but I could not do that, and I'm not getting any answer from Facebook also. Maybe they're not clear. So what I decided to to record live for all these shareable papers which I'm getting from downloaded from internet. uh, I try to find. I spend a lot of time to search these documents, because these are reference documents. You can say resourceful document. This I try to find from there and record them, and then share them. I'm going to say screen share, because I cannot show directly from here through this video camera. I don't have I don't have hard copies of what was filed. So I just want to share on screen, and that's, you can say, I have just make that separate videos of screenshot. It's not done relinkable. If I try to relink them to this camera, but it's not working. Or it stops and the screen becomes black. Though it should not be, but there's some, I think, technical problem. So no problem. We go this way. We have solution that we record them separately. I have recorded this, and I shall also record some more files of maybe today or tomorrow, not tomorrow night. And then I record some soil reports that I have, one or two soil reports, actual project soil reports. Actually, that's the purpose that I want to share with you. Those are descriptive one and practical work experience. I have tried to share those with you. That's my thought. So I was just trying to find a solution how to provide you that file, and I also recorded those files somewhere on live.com. I think it is, and URL is also given there in same list of URLs in this text at end of this text before safety URLs. Those files are available there. If you want to download them, you can download, because I could not upload these files on script.com due to it refused, to say, oops on that. There's some wrong. So I just put them on live.com, but I think you will download from there if you wish, or when I do a screen share of that file, you can use that one. So this is, solution in parts. This, you can say, thing is also required how to handle. When you write to Facebook, I never get any reply from them. Maybe they are very big people. They have no time to respond. So this file which I shared with you, this is thermal conductivity of soil. This is it is having some pages, 29 pages, and we have already discussed about these pages. Many of these means heat transfer capability through a substance by conduction, and thermal resistivity, also referred to as RHO, is form, simple form. Then theory, measure, and studies, we have taken up references in that. So this we have already gone through. It's given as never use standard values, understand water content, density effect RHO. RHO must be measured. Consider site, consider site specific variables. We have already gone through that. T1 never used standard values. So all these descriptions were there, and thermal properties we discussed about volumetric heat capacity, we discussed about density, we discussed about thermal resistivity, and we discussed about thermal conductivity. These four parameters for functions we discussed. Okay, and then we say look at variables we discussed there, and table 1 regarding various materials, their density, thermal conductivity, thermal resistivity, and volume heat capacity. That's for quartz for soil, minerals for granites and for organic matter, for water, for ice, and for air. We discussed this: what's density, what's thermal conductivity, what's thermal resistivity, and what's volume heat capacity we discussed. And we also discussed what to learn from these models, some figures, some hints regarding the soils, water content relation to its thermal. Let me blow up this better. To its thermal thermal resistivity relation that is in organic loam and quartz soils in relation to water contents, thermal resistance, how much. And there are three curves which are given here as we discussed yesterday: organic soil, loam, and quartz. And then we also talked of here, what to learn from models, and these are all models. And it says that in some mention here, without knowing anything about weighing factors for this in actual soil or fill material, four things should be clear, and that's a description of this in this paper. And it's about, you can say, air is bad and organic matter no matter how wet, and of course replacing air with water and fill materials. And then there's a diagram, you can say figure diagram type, which is giving quartz and other soil minerals and waters and organic matter. Some graphic is there for thermal resistivity, that lowest is quartz, and then other soil minerals, and then you can say water, and then organic matter. So in range it is given towards rising value. Lowest is quartz 11, and other soil materials of 40. Water is 172, organic matter is 400, and air is 3846. This range is given. Then there is given T2, that's another chapter which understands water content. What's water content in soil, what's air content in soil, what's crystalline nature of other materials, can say. Draining, a quick draining soil like coarse sand respond differently to precipitation than a fine silt soil. Asphalt and concrete coverings like other sites, they already protect this water to reach there. This is water content field we discussed, and we also discussed critical water content. And it's again same thing with them. It's a temperature-based criticality, which is based on temperature of 25 degrees Celsius and 50 degrees Celsius. Then we discussed about density effect RHO, how density is related to that, and this is there in content of various thermal resistivity and density. You can say how density is related to that. It's there, bulk density is this, and how this graph works. We just compare that, and we learn that now. And then say grading counts, how grading is that lessons, six lessons that are soil thermal resistivity, computation, soil composition, and increasing soil, and you can say compaction solid, and you can say tampered, all like this. Then T4 is RHO. RHO must be measured and should be taken from site to solve gives, and consider site specific variables. That is T5 again means unique situation and watch surface, and you may say consider consider engineering backfill material and hard spots means how to handle this site. If the variable says In addition, in addition to issues discussed above, there are also several site-specific issues that need be taken into account when designing and implementing underground power cable systems. Those, those include depth of burial surface conditions, backfill and surrounding vegetation, and then hotspot section, and then you can say measure what measure is to take or solutions like two ways to test and create a dry out curve, things to keep in mind, and that is, yeah, just like two ways to test is field testing and lab testing and create a dry out curve. Then things to keep in mind is oven dry versus air dry. Oven dry versus air dry, I'm talking of sample this, and methods for methods for clay soils and finding RHO at maximum density, temperature consideration, reporting RSO, and standard ASTM, etc. Two ways to test. This was another one, field testing, and also you can say this is lab testing. Then create a dry out curve. We discussed how to prepare sample and then test in laboratory dry out curve by training. Then we started creating a dry curve. How we do that? The complete sequence is given there. Formulas are available there, RHO and D, and all details are there. We spend time on that. We can, and there's a figure here by graphics, and there is a explanation of that formula which can, and things to keep in mind about oven dry versus air dry, methods for clay soil, finding RHO at maximum density, temperature consideration, and then M4 is reporting RHO, heavy report what you get in that, ASTM standards, and likewise we go studies, what we studies wind farms, data centers, public utilities, underwater cables. We did that, and then wind farms is shown there, data centers are shown there, public utilities are shown there, and under underwater cables, and then references are references of all those authors that have been considered along with this say this file. So this file has given us, a brief about what is soil conductivity, what is resistivity, and of course, relation to electrical heating as well. How to, how temperature of soil is affected, how heat resistivity or heat transmission is affected, depending upon water contents or when heated soil is heated naturally, how it affects. How can there be cracks if suppose soil is of clay and there is Mount Morolite in that, how that can affect that one. That's completely mysterious types of discussion, but very important one because science says until you understand them, you cannot understand the engineering of that because it's not simply cleaning room, it's cleaning completely. That's very important. We should understand these points in all respects. This file gives us some similar details. If we add some formula here, dry out sample, for example, and we have to get all these points. This was just like I can say, thermal conductivity is very important. Thermal resistivity is very important because ultimately we say cables are there below, which can be heated up and can go. And therefore, we provide armored cables in generally all underground services. Armored cable is stronger than ordinary cable. Even then, heat is heat. You cannot say no. So that point we must take into our consideration. Moisture, important point is moisture, air, voids, and density. These are very important points, in soil engineering. When we are talking now, whole everybody is talking how to protect means soil is unforeseen. As you can say, you cannot say anything. Soil this shall happen this into soil. So thereby this book is, to say, this page was important and explanatory. I took some time to read that to explain to your people. That's very important. Now I'll close this file because this file, if required, it'll open again, no problem. Now I'm going to start a file. It's a Mount Model United file, Mount Model United file, which I uploaded uploaded, and I'm taking it out from file folder, and I'm into this file folder. That's Mount Molite one. I'll start with one, and then I'll get to part two then. So let me go to this and open this file, Mount Molite. This is here in my DES, and I go to dictionary, my folder soil, where soil here gone somewhere. Yeah, its soil is here. Then I'll open this. There's so many files. I put more files even than now here. And this we discussed today. We have to discuss this Mont Morillonite Introduction to Paper Utilization. This is here. Let me see which one I have to open. Yes, now I have opened this page, and this file I opened, uh, Mont Morillonite. Mm, just blow it up. Now, first of all, because I'm starting this file to talk of, then we'll see what does it say. This is about 17 pages, and this is the introduction to properties and utilization. And that is, sorry, this is uh, now there is a note on this. Let me read this note if it is beneficial to you. First of all, let me tell you that this is a reference from site, that's www.intechopen.com. That's books, current topics, and that's all. Now it's given what's open access. Just for reference, I'm telling you, nothing to do with smart knowledge is written. What is open access? Open access is an initiative that aims to make scientific research freely available to all. This is open access, means it's support was you can say indirectly. And open access is an initiative that aims to make scientific research freely available to all. To date, to date, you can say, because this is wide and one. To date, our community has made over 100 million downloads. It's based on principles of collaboration, unobstructed discovery, and most importantly, scientific scientific progression. As PhD students, we found it difficult to access research we needed, so we decided to create a new open access publisher that levels playing field for scientists across the world. How? By making research easy to access and puts puts academic needs of researchers before business interest of publishers. Now, and our authors, and just reference to authors, I'm just will give, we as community of more than 103,000 authors and editors from 3,000 to 291 institutions spanning spanning 160 countries, including Nobel Prize winners and some of world's most cited researchers. Publishing on Intact Open allows authors to earn citations and find new collaborations, meaning more people see your work not only from your own field of study but from other related fields too. Now, content analysis there, I don't think so. A brief introduction to this section that describes open access, especially for an intake open perspective. How it working? how it works, so manage preferences, context, etc. Now, and we'll say now it is I'm leaving this page, going to other page, and that is now that's page two, and it's now what does it say? Let us say is in abstract is written on that. This was abstract, and let me read this abstract for you. Hmm. Now it says about clay mineral. Clay mineral is an important material. Clay mineral is an important material available in nature. Available in nature with an increasing understanding of clay structure. Mount Morillonite is realized viable for an enhanced performance in a variety of materials and products in areas of catalysis, food, and say food additive, antibacterial function, polymer, sorbent, etc. Significant development in use and application of Montmorillonite is seen in recent time. Now, this chapter provides an overview of Montmorillonite structure and properties, and particularly discusses its recent utilization in important materials. Montmorillonite is introduced in terms of its natural sources, chemical structure, physical and chemical properties, and functional utilization. Important physical and chemical properties are summarized as particle and layered structure, molecular structure and cation exchange effect, barrier property, and water absorption. This is followed by important functional utilization of montmorillonite based on effects of its original effects of its chemical structure. Important functional utilization of montmorillonite includes food additive for health and stamina, for antibacterial activity against tooth and gum decay, as sorbent for non-ionic, anionic, and cationic dyes, and used as catalyst in organic synthesis. In structure, no, sorry, structure. I think I made a mistake. This is followed by important functional utilization of montmorillonite based on effect of chemical structure. Important function utilization of montmorillonite additive for health and stamina for antibacterial activity against tooth and gum decay, as sorbent for non-ionic and organic as synthetic. Environment concerns to date do not indicate adversity for particles used as additive. Studies be useful clearly are based on molecular structure to describe environmental effects. Absorption. One word, please. Just trying to find the word meaning. So absorption. No, it's not that. Yeah, it's not that. Mhm. Yeah, yeah. Absorption. Absorption. Definition: sorption is a physical and chemical process. Sorption, S-O-R-P-T-I-O-N. Sorption is a physical and chemical process by which one substance becomes attached to another. Physical and chemical process. Okay. So is absorption same thing. Specific cases of sorption are treated in following articles. Sorption. Okay, we understand that. Right. So we move to saying now. We just try to get that word meaning in that just little not clear. No problem. So now we come back to same file and we can say so I close here. So we can say now chapter and author information here. This is introduction. This page is the introduction page before and historically we can say historically clay mineral has long benefited human life. I'm going to take the complete file historically. It is because it will be little different. Historically, clay mineral has long benefited human life and civilization. Being an integral part of Earth, its history is older than creation of man. Divine script of Holy Quran confirm that man was created using clay. Okay, no problem. We are all clays. This indicates that clay clay mineral was present before human life began on Earth. Ancient Greek philosophy and culture considers considers clay an important component of life. Currently, 21st century is process of appreciating even growing number of clay applications in material science. In times when technology wasn't at core of human civilization, clay mineral was used as an important form of material to form a variety of products. Its softness, plasticity, porosity, tangibility, and pliability, and climatic adaptability all at affordable cost were viable characteristics to recognize its usefulness and introduced several products. Today, when nanotechnology is hallmark of scientific world, contribution of clay mineral is significantly visible as highly useful fillers or additives in polymers for desired effects. Nanoclays based on Montmorillonite are currently used to modify polymer performance. Science of science of clay was introduced since prehistoric times. Ceramists used nanoparticles since an- antiquity. However, nanotechnology is knowingly knowingly you can say science scientific utilization scientific utilization of nanoparticles. Use of kaolin may be tracked back to third century third century BC in China. China clay, a traditional name of kaolin. China clay, a traditional name of kaolin, Kaoline, is a minerals, mixture of minerals generally containing kaolinite. Mixture containing kaolinite, quartz, mica, feldspar, illite, and montmorillonite. Science of clay. Science of clay was introduced since real development's time. I am repeating, ceramists used nanoparticles since antiquity. However, nanotechnology is knowingly scientific utilization of nanoparticles. Use of use of kaolinite may be based use of may be tracked not based tracked back to third century third century BC in China. China clay traditional name is kaolinite is mixture of minerals generally containing kaolinite. Then agriculture. Then you can say kaolinite, quartz, mica, feldspar, rhyolite, and montmorillonite. Now, historically, use of clay is known in architecture, industry, and agriculture. Production of sun-dried, and fired bricks for building construction still follows century-old procedures. Floor tiles, ceramics, earthenware, and pipes for drainage are examples of clay-based products used since ages. An interesting behavior of clay in producing products is its ability to swell and to mold in water and retain shape of a container when dry. A common characteristic of clay mineral is a fine-grained natural structure. A fine-grained natural structure in a sheet-like geometry. Sheet-structured hydrosilicates. Sheet structures hydrosilicate are generally called phyllosilicate, PHYLL. Phyllosilicates, natural clay, natural clay particle is smaller than 0.0004. Then smaller than 0.004 mm in diameter that may range from 0.002 to zero point zero zero 0.001 millimeter for quartz, mica, feldspar, and aluminum oxide. You can say, we'll say, a common character of clay material mineral is a fine-grained natural structure in a sheet-like geometry. Sheet-structured hydrosilicates are generally called phe- phyllosilicates. Phyllosilicates. Natural natural clay particle is smaller than 0.004 mm in diameter that may range from 0.0002 to 0.001 mm for quartz, mica, feldspar, iron, and aluminum oxides. Colloidal clay particles are finer and found in layered silicates less than 0.001 in diameter. Clay minerals may be grouped in future steps. Group members vary mainly in layered structures. These include Gallonite group, Gallonite group, Smactite group, Montmorillonite group, Elite group, and Chlorite group. So this was history of this. Let me just come after 1 minute. I'll feed. It's already 5 o'clock. You hold on. I'll feed my girls food. Just 1 minute. back. Yes, also my job. All right. Let me some water also. So I was talking of history of clay. Brief history, though there's more history in clay if you know yourself. If you have experience in our country, in villages particularly, where people don't have much money, or there was no concrete and bricks or stone, something like that in our villages, we can say proudly in our villages, if you have noticed, might be in north or in south, wherever you go, particularly in north, you must have seen some, pitch type houses. Though now they have deckable houses, but in past, if you see, when I was too young, I used to go to some village. We used to see that some brickwork done in mud mortar, or they call it mud actually. It's clay and some, sometimes they use some cow dung. It's bhusa type, it's chopped from this, crops material. They call it bhusa, or I don't know what name in English. They mix it with this clay and used to do floor work or wall plaster or even masonry joints. Clay, it is because chickeny when not so this Mount Moralite or Carolite. I don't know that which was that, but we never knew about that. But in winter it used to be hot, and in summer used to be little cold. So you can say it is natural because it is refractory material, and it helps you. It digests thermal energy, I think, and it helps that clay mineral it is. And every week, I think every week or every day, yeah, they used to clean this by sponge of same soil. So that's why these clay houses, mud houses, they used to call them, like, and they were happy in that. And there are many applications we have in our daily life, like water pitcher we use, we use to some, a spherical, little spherical and vertical sphere cylinder type. So water you put and you let it, it's a conditioned water, you can say, and pitcher also is conditioned water. And so this is what applications are, still many people do that. And we are not using this clay now in our houses because we have got structural arrangements, we have got, cement with us, and we got many types of advanced materials which were scarce those days. So we can say we should understand still clay is a material, a soil that is available all over the world, in our country, in others countries, in many countries. This we have to understand its importance, and we there's no way that we can ignore it. Ignoring is no issue, and it's one of many refractive materials. Refractive means those can withstand higher temperatures. This can, and just the example was calumet. This is China clay, it's having so many compositions of various materials. And similarly, many chemicals in Mount Morillonite will learn that. I just remind what we learn is that it's said about kelonite in this case, which is, I repeat that one, it's important one regarding kelonite, which is, I think, it's on, hmm, I think there are 4 or 5 lines if I can read them. One is historical, that's okay. Other one is times when technology was not core of us, that's okay, fine. when you can say, sorry, then you can say there was nanotechnology, hallmark, and science of clay was introduced in prehistoric times. Ceramics used nanoparticle sensor. Okay, yeah, this is containing colonite quartz. So it says that, however, nanotechnology is knowingly scientific utilization of nanoparticles. The use of kaolinite may be tracked back in third century uh, mixture, third century BC, third century before Christ in China. China clay, China clay, a traditional name of kaolin, a mixture of minerals generally containing kaolinite and quartz, kaolinite quartz, mica, feldspar, illite, and Montmorillonite. This is what it contains. Remember what does it contain? It contains kaolinite contains means what? Kaolinite contains is containing kaolinite quartz, kaolinite, quartz, mica, feldspar, illite, and Montmorillonite. China clay contains kaolinite. Kaolinite is one of these clay soils. Kaolinite, quartz, mica, feldspar, illite, and Montmorillonite. This is the important part, and then you can say a common characters of clay mineral is fine-grained natural structure. Remember this, it's fine-grained natural structure in sheet-like geometry. Sheet-structured hydrosilicates are generally called phyllosilicates. Phyllo, Phylo, PHYLO, silicates are natural clay particle is smaller than 0.004 mm in diameter. I think it's still higher, should be lower. That that you can say may range from uh, 0.002. This is natural clay particle is this, and but that may, that may be 0.002 to 0.001. That's actually right. It's for quartz, mica, feldspar, iron, and aluminum oxide. Colloidal clay particles are finer and found in layered silicate that is less than 0.001 millimeter diameter. Now we have clay minerals and we have to group them. Group members vary mainly in layered structure. These include kaolinite group and smactite group, that is Montmorillonite group. Montmorillonite is the smactite, says smactite, Smectite. These include kaolinite group, one is kaolinite group, other is smactite group, and spectite means Montmorillonite group, then illite group, and then it's all. So kaolinite, here is kaolinite, which is member minerals are kaolinite is means kaolinite, dicite, and NaCrite, nacrite. And its general formula is Al2Si2O5. Al stands for aluminum, Al2, Si silica, Si2, O5, and then bracket OH sub point is 4, OH4. Members are in this polymorphs composing of same formula and different structure. That is polymorphs. Remarks it is. And other one is smectite. Smectite one is kaolinite group, One is smectite group and one is illite group. So smectite. We are reading now. Montmort illonite. It contains members and minerals in smectite. One is Montmort illonite, other is pyrophyllite and TALC, vermiculite, sauponite, saponite, non-tronite. So there are about this Montmorillonite in this as the smectite, Montmorillonite, pyrophyllite, talc, vermiculite, sauponite, saponite, non-tronite. In this, our general formula is CaNaH in bracket CaNaH. Next one is bracket AlMgFeZn and bracket 2. Then it is, this is for, then it is, other one is bracket SiAl 4 bracket 4 O10 bracket OH2 and XH2O. This is this one, and then it is okay. In this X indicates here, X we are using with H2O. X indicates varying level of water in mineral type. So third one is illite, that is illite. Member is illite. Only illite is member illite. And it is formula, you can say general formula, bracket KH Al2 bracket Si and Ai for O10 OH2. X indicates varying level of water in mineral type. So this is, you can say, illite. So we have gone through what? Three groups. Group 1 is scalonite, that is scalonite, dictite, nacrite. Other one is smectite, montmorillonite, pyrophyllite, talc, vermiculite, sauconite, saponite, non-tronite, and is illite, that is illite. So in first case, members are polymorphs composing of same formula and different structure. Other case, that is you know smectite. Smectite, this X indicates varying level of waters in mineral type, and then other X is the third one, that is calonite, illite. This X indicates varying level of water in mineral type. This is table that gives about clay minerals may be grouped in four types of shown in. Group members may vary mainly in layer structure. These include galenite group, smectite group, illite, and then we go to now this, there are fourth one. This is still not complete. I'm saying is illite, we said this illite which continues in number 3, and it is amesite, then chamosite. Amesite is also with illite in number 3, amesite, that is Mg. Its formula is Mgfe bracket 4 Al4 Si2O10 bracket OH8, and then other one is chamosite, that's bracket FeMg 3 Fe3 AlSi3 O10 OH8. Then fourth is chlorite, cookite, 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 and one is limite, and so on. Cookite is LiAl5 Si3O10 bracket OH8. Each member each member mineral has a separate formula. This group has relatively larger member minerals and sometimes considered a separate group, not as part of clay. This is yours. Cookite and Naimite and so on. Naimite is Ni bracket Ni Mg FeAl 6 AlSi3 O10 OH8. That's all. So how many are four groups? If you see now, one is kaolite, kaolinite, other is smectite, third is illite, and fourth is you can say chlorite. In one kaolinite, dictite, lactite. In other one smectite, montmorillonite, pyrophyllite, talc, and vermiculite, succoolite, sapoolite, non-tonic, and then elite is elite, and then is amesite, elite, amesite, chamosite. And that is formula for amesite is there, formula is there, and now we've gone through this formula and cookies, then cookite. Now table 1, major groups of clay minerals. Table 1, major group of clay minerals. Major group of clay minerals says no, it's okay. Just stretching my body so that I don't be lazy. Just to avoid laziness. Because continuous reading to me is a problem. So I just do that. Well, what it says, this is major groups of clay minerals. Now table 1 it is, and you can say let me down this one. Almost two down, almost one, but okay. That's a little different way here, so that I can get water. Come on. It's very important. Just the same way I get wind as well as you know. Kaolinite group. Kaolinite group has three members, including kaolinite, dicite, and necrite. Formula for kaolinite group is Al2 Si2 O5 bracket OH4. Illite group is represented by mineral illite. Only common clay type. General formula for illite is KH bracket Al2 bracket SiAl4 O10 bracket OH2 XH2O. It is an important rock forming mineral. It's an important rock forming mineral and main component of shales. Main component of shales. This is this we can call it elite group. Structure of this group is similar to Mont Morillonite group with silicates layers sandwiching an aluminum oxide hydroxide layer. Now, chlorite ground, chlorite group is relatively large. Chloride group is relatively large. This group is not necessarily considered as part of clays. Chloride group is relatively large. This group is not necessarily considered as part of clays. Therefore, it is placed as a separate group in phyllosilicate. Members in chloride group are mesite, chamosite, cookieite, definite, and definite with varying formula and structures. There is no general formula. Variety of clay mineral is based on arrangements of tetrahedral. Variety of clay mineral is based on tetrahedra, tetrahedral and octahedral sheets. For for example, 1:1 clay mineral would have one tetrahedral and one octahedral sheet. Tetrahedral, what octahedral sheet? Mont Morillonite is an example of clay mineral having 2:1 sheet structure and 2:1 clay. Wait a minute, let me finish it completely. I missed something. Yeah. Let me read this paragraph again. Variety of clay mineral is based on arrangement of tetrahedral and octahedral sheets. For example, 1:1 clay mineral would have one tetrahedral and one octahedral sheet per clay layer. 2:1 clay mineral would contain two tetrahedral sheets and one octahedral sheet sandwiched between two tetrahedral sheets. One octahedral sheet sandwiched between two tetrahedral sheets. Mont Bernite is an example of clay mineral having 2:1 sheet structure and 2:1 clay mineral are composed of octahedral sheet adjacent to 2:1 layer. 2:1 layer, that is Mont this is octahedral sheet adjacent 2:1 layer. You see, then it is 2:1 sheet. This is the Mont Morillite, and 2:1 clay minerals are composed of an octahedral sheet 2:1 structure. 2:1 clay minerals are composed of an octahedral sheet adjacent to 2:1 layer. It says that. Hold on, please. Hold on. So 2:1 is Mont Morillite, an example of clay mineral having 2:1 sheet structure And 211, 2 is to 1 is to 1. Clay minerals are composed of an octahedral sheet adjacent to 2 is to 1 layer. Sheet sheet structure for layers of various clay minerals with possible charges in shown in now. I will show you this sketch also in a minute. I'll, before that, let us say what we study so far is table 1. Studied here, calonite. That is calonite, and this is clay mineral group. This is we can say layer type, and this is layer charge. These are columns here. So what I say is one is calonite, other one is Montmorillonite or smectite, and one is illite, and one is vermiculite, and one is vermiculin. So Montmorillonite are smectite, and illite, vermiculite, and chlorite. These are these are clay. These are clay mineral group. Kaolite, Montmorillonite or smectite, illite, vermiculite, and chlorite. Now, what they are can say layer type is in you can say in calonite 1 is to 1, in Montmorillonite 2 is to 1, in illite 2 is to 1, in vermiculite 2 is to 1, and in chlorite 2 is to 1 is to 1. These are there in the mega and layer type. Then in this layer type, first is 1 is to 1, and that is less than 0.01 charge. This is a layer charge, and other one is 2 is to 1, which is 0.5 to 1.2. Then it is third one 2 is to 1 again, that is 1.4 to 2, and then 2 is to 1 is 1.4 to 2, and 2 is to 1 is 1.2 to 1.8, and 2 is to 1 is variable layer chart. This is then we go further, and let's table 2 structure for layers of clay mineral. Structures for layer of clay mineral. Natural reserves. Natural reserves of Montmorillonite. I'll say I'm feeling some problem here. Natural reserves of Montmorillonite are present in various parts of world. Let me see how I feel. So button is missing. A button is broken. Hmm. No problem, button is broken. I can't give top button all time. Let this one is enough for them. No issue. Now, what I was saying, this natural reserves of Mount Mor Illinois are present in various parts of world, right? Various parts of world. An earliest, you know, discovery of Mount Morillite was indicated in 1847 in Mont Morillon in Vienna, prefecture of France. However, use of Mont Morillite for medicinal purposes may be in over 2,200 cultures, including ancient Egyptians, pre-Aztec, pre-Aztec, Amargosians, Amargosians, I think it should be pre-Aztec, Amargosians. I think it's not related to Amargosians, Amargosians, Gosians, Usians, Amargosians, and the native of Mexico and South Americans. South Americans and North Americans. Names used for Mount Morillonite are known in different languages. These are known in different languages, including Mount Morillonita, Mount Morillonita. This is Portuguese, Catalan, and Spanish. Then Mount Mor Illonite, Montmore Illoniat, NIET, Montmore Illoniat. This is Dutch, and Montmore Illonit is German, Hungarian, and Slovak. Mm. And you can say Montmore Illonit, German, Hungarian, Slovakia. Then the major Mount Morillonite deposits found at five. All right, name in Mount Morillonite deposits found in five places, including Himalayas, that is China and Urals, Pakistan, Caucasians, Georgia, Russia, Andes, Peru, and Ecuador, and Wasatch, US, UT. Now, bentonite, bentonite. It's well-known material. It's well-known material and used in boring, rigging sometimes. Bentonite is an important rock of clay. It's rock of clay. Bentonite is an Important rock of clay found in nature. It's an important source of Mont Montmorillonite, Mont Montmorillonite in nature. It's rock formed of highly colloidal and plastic clays. It's rock formed of highly colloidal and plastic clays, mainly composed of montmorillonite in addition to montmorillonite, benitopenite. Mm. Sweating in 89% humidity. What to do? No, no wind, nothing. 89%. See my pasina. Oh yeah, I put a one friend what to do now. So say I would say this that important rock it is of monazite nature. It's rock from highly colored plastic clays, mainly composed of montmorillonite in addition to montmorillonite. Bentonite Bentonite may contain some amount of crystalline quartz, crystallite, and feldspar. This is in addition to montmorillonite. So, bentonite itself is not montmorillonite, but rock which contains also in addition to montmorillonite, which amount of crystalline crystalline quartz, crystalline quartz, and crystobelite and feldspar. These are in addition to may contain also rock, not necessary. So we can say Montmorillonite plus crystalline quartz plus crystobelite plus feldspar means bentonite. Variety of bentonite applications are result of its useful and interesting chemical and physical. Where are you? What happened here? What happened to this? Why you hung up? Why are you hung up? It hung up. Variety of bentonite. So our results are, wait a minute, variety of bentonite applications are result of useful and interesting chemical and physical properties, chemical and physical properties. That's bentonite. Says application, variety of bentonite applications are results of its useful and interesting chemical and physical properties. Range of properties include rheology. All right. So it is range of properties include rheology. Rheology, RHEOLOGI. Sorbent effects, effects, and plasticity and lubricity high. high drive, high drive, high drive bonding strength, high strength. Rheology, reset, R-H-E-O-L-O-Y. What is rheology? Rheology, solvent, we have no solvent effect and plasticity and lubricity. And if you want to see rheology, we have to go to mind. Yes, study. Why submit this, to understand rheology. Rheology. Hmm. Rheology is this means this is study of study of flow of matter primarily in a liquid or gas state, but also in soft, solid, or solid under conditions in which they respond. The branch of physics and rheology definition is science dealing with deformation and flow of matter. Hmm. So it's that. Understand this now. So we can say clearly now what does it mean rheology and sorbent effect proplasticity and lubricity, high dense, high dry bonding and oil then can say sorbent affects plasticity, lubricity, high dry bonding strength, high shear and high shear and and compressive strengths, impermeability and low compressibility. So a variety of bentonite applications are results of its useful and interesting and chemical and physical properties. This is range of properties include rheology, light. Okay. Then we go to natural bentonite. Natural bentonite particles are indistinguishable from kaolin clay. That is, natural bentonite particles are indistinguishable from kaolin clay minerals viewed under scanning electron microscope. However, main difference main difference indicated was thickness. So there's a difference, in natural and in other one. So we repeat that natural bentonite is different. Natural bentonite particles are indistinguishable from kaolin clay minerals. Clay minerals are viewed under viewed under scanning electron microscope. However, main difference indicated was thickness. Sodium or potassium salts of bentonite exfoliate into thin plates. So we can say now, repeat. This is about natural bentonite. Let me just stand for a while. I think I'm a little bit lazy here, right? If I can see, I can just for 5 minutes I stand to just see. Looks. Let me just close this my and let me stand for a while just to read that. Sometimes you feel lazy, so I don't know if I'm lazy here. I just stand for a while and see. I lose I can say here as well. I see for a while I can say. So let's say natural bentonite particles. Natural bentonite particles are indistinguishable from kaolin clay minerals. Natural, is my space. Natural bentonite particles are indistinguishable from kaolin clay minerals viewed under scanning electron microscope. However, however, main difference indicated was thickness. Sodium or potassium salts of bentonite exfoliate into thin plates. In general, clay minerals based on bentonite clay, bentonite may exhibit properties of thixotropic gel formation. Thixotropic gel formation. Let us see this. What can I do? I don't know. Just want to relax. There will be tension. So I do this way. I just want to relax. I can say it says general clay minerals based on bentonite may exhibit properties of thixotropic gel. Some not they go track, different track. It's different. Natural bentonite particles are indistinguishable from kaolin clay minerals viewed under scanning scanning electron microscope. However, main difference indicated was thickness. Sodium or potassium salts of bentonite exfoliate into exfoliate into thin plates that could be of 1 nm, 1 nanometers in thickness theoretically. In general, in general, clay minerals based on bentonite may exhibit properties of thixotropic gel formation with water. high water absorption, and high cation exchange capacity (CEC). These properties could be varied in clay minerals depending upon nature of interstitial waters, and exchangeable cations in interlayer space. Bentonite, consist which mainly contained Montmorillonite. Bentonite, which merely contained Montmorillonite, was discovered in about 1890 in USA. A name bentonite is associated with name of American geologist for one time Fort Benton in eastern Wyoming Rock Creek area, USA. Montmorillonite derived from bentonite. Montmorillonite derived from bentonite. Montmorillonite derived from bentonite. Oh, यार ये मने है यार. Montmorillonite derived from bentonite may contain sodium or calcium. Sodium montmorillonite is main fraction in bentonite found in combination with 10 to 20% of various minerals including including uh, feldspar, calcite, silica, and gypsum. Now, physical structure of physical structure of montmorillonite particle is generally perceivable. Physical, physical physical structure of montmorillonite particle is generally is generally perceivable in sheets and layers. Each layer is composed of two types of structural sheets. Each layer is composed of two types of structural sheets, octahedral and tetrahedral. Octahedral and tetrahedral. Tetrahedral sheet is composed of silicon oxygen tetrahedra. That is, tetrahedral sheet is composed of silicon oxygen tetrahedra. Linked to neighboring tetrahedra by sharing three corners. Linked to neighboring tetrahedra by sharing three corners, resulting in a hexagonal network. Remaining fourth corner of each tetrahedron forms a part to adjacent octahedral sheet. Each tetrahedron forms a part to adjacent octahedral sheet. Octahedral sheet is usually composed of aluminum. That is, that octahedral sheet is usually composed of aluminum or magnesium in six-fold coordination with oxygen from tetrahedral sheet and with hydroxyl. Two sheets together form a layer. Several layers may be joined in a clay crystallite by interligation by van der Waals law forced by electrostatic forces and by hydrogen bonding. Theoretical formula and structure is indicated. Important natural physical properties of Mont Blanc are given in best field. Indicators are softness, color, water, soapy feel, and expansion with water absorption. So, so this is some information I'm getting in for bentonite based monomonolinite. You can say bentonite. Now again, I'm giving you this last para, or I'll say all. Let us say physical structure. Monomonolinite structure is monomonolinite structure. I'm talking physical structure of monomonolinite particle is generally perceivable in sheets and layers. In sheets and layers. Mhm. Sheets and layers. Okay. Each layer is composed of two types of structural sheet. Two types of structural sheet. Each layer is composed of octahedral and tetrahedral. Octa means 8 and tetra means 4. Octahedral and tetrahedral. Tetrahedral sheet is composed of silicon oxygen tetrahedral linked to neighboring tetrahedra. Same sheet, same layer is linked to the sheet linked to neighboring tetrahedra by sharing three corners. Sharing three corners, reinforcing by sharing three corners, resulting in a hexagonal network. Remaining fourth corner of each tetrahedron form forms a part to adjacent octahedral sheet. Octal octal magnesium octal magnesium in sixfold coordination with with oxygen from tetrahedral sheet and hydroxyl sheet. Oxygen from tetrahedral sheet and with hydroxide two sheets, two sheets, together with together with forms a layer. So together forms a layer. Two sheets together forms a layer. Several layers may be joined in a clay crystalline by interlayer cations. So it is several layers may be joined in a clay crystalline by interlayer cations by van der Waals forces by 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 electrostatic force or by hydrogen bond. Theoretical formula and structure as indicated important natural physical properties of molten molecule are given in best felt to indicate of this. So let's sit little now. Just yeah, so it is now M say it is My bracket Al2 and I think not My it is it's comma is looking Y actually it's M and Al2 and by MGY SL4 O10 OH2 and NH2. You can see on this page four structures given and van der Waals forces also given and you'll find various indications there. If you see this page on your monolith file one, you'll find this. Mm. I can also do a photograph of it. Wait a minute, let me take some photograph of this because it's a little interesting. Just black and white doesn't matter. Let's take a photograph of this. I think it's there, right? Oh, it's there already. It's there already, right? Yeah, it's there. I think that's right. Yeah, it's there. So I can show you that again. I think yesterday maybe I showed to you. I don't remember exactly. This Vanderbilt forces here. See Vanderbilt forces here, and So now we'll move further now. Now we discuss about figure 1, and that's theoretical formula and structures of monomer source nanocore. Now start. See that. Okay, now we go further without the laziness. This is page 4. We go slow in this because we have to understand this. Understand really what we have to understand is density. Density is 2 to 3 gram per centimeter cube. This is measured one. Density is 2 to 3 gram per centimeter cube. And crystal system. Crystal system is monoclinic. Monoclinic. After that, hardness 1 to 2 on Mohs scale. Soft causes fine grained occurrence. Fracture, irregular, uneven. Cleavage perfect. Luster earthy dull. Transparency translucent. Then it is transparency is translucent. Okay. So what we say, regular, even, perfect, luster is dull, earthy, transparent, translucent, and color is color. That's the point here. White, that is buff. White, buff, you can say yellow, green, rarely pale, pink to red, presence of high valence amine process produces a pink to red coloration. So this is buff, yellow, green, yellow, pale, pink to red, presence of high valence. Amine produces pink to red coloration. Table 3. So what is this property we are on? Let's say density is 2 to 3, right? 2 to 3 gram per centimeter cube. So it's not that light, you can say. 2 to 3 is not. It's somewhere like weight of concrete, you may say. Then, then it is crystal system is monoclinic, and monoclinic means then hardness is 1 is to 2, 1 to 2. On Mohs scale, soft possesses fine grained occurrences. Fracture is irregular, uneven, and cleavage is perfect. Luster is early dull, and transparency is translucent. Color is white, buff yellow green, rarely pale, pink to red, presence of high valence men product looks like so. In table 3 is important natural physical properties of monomer. Let's not do both things. Because yes. So important natural physical properties of monomer are variation in chemical formula. Variation in chemical formula of monomer. Variation chemical formula of monomer is possible, resulting from modifiable structure, resulting from modifiable structure. Cation cation substitution introduces charge imbalance. So cation substitution introduces charge imbalance. Therefore, chemical composition can vary. Exact theoretical formula yes, exact theoretical formula is never seen in nature. However, structure in nature in any form consists of water molecules. Motor, yes, yes, I think so. Mm. So, this is scratch. So, variation in chemical formula of monomer is possible, resulting from modifiable structure. That's possible. So chemical formula for Montmorillonite discovered a Montmorillon for Montmorillonite discovered at Montmorillon, France is France formula Ca 0.14, Ca 0.14, G8 base, Na base 0.02 bracket 2 bracket, and then sum of 0.16 bracket A aluminum base 1.66, Mg base 1.0.16 means, and Fe 0.04 bracket close, and sum again 2.08 bracket Si3 Si0 Si 3.9 and Al 0.1 and bracket sum 4 base 0 plus 10 OH2 102 H2O. So this is you know 2.08 Si 3.9 and Al 0.1, sum equal to 4 O10 OH2 1.02 H2O. It's quite lengthy formula. It's very boring, of course, but we have to study. Problem is not that boring or not boring. We have to study. Next is oxide composition. Oxide composition comprises silicon and aluminum oxides. It was predominantly calcium montmorillonite discovered at Montmorillon. Dominant fractions were SiO2, Al2O3 was slightly more than 50% of total oxides. क्या करेगा यार ये क्या क्या नहीं सुनता ये स्केचिंग ह्यूमिडिटी भी ज़्यादा है व्हाट आई डू काम भी करना है स्केचिंग जहाँ चल जाती है सभी को हटती नहीं है हाँ तो गेल लगी यार क्या करोगे रुमाल भी लग यहाँ रखा है रुमाल भी रखा हुआ I think that will help. Let's move further. Sorry for disturbance. It's happening tremendously. It shouldn't happen. I said oxide composition comprises silicon and aluminum oxides. However, it was predominantly calcium montmorillonite discovered in, but it is predominantly calcium montmorillonite montmorillonite discovered at Montmorillon. Dominant fractions were SiO2, SiO2 and Al2O3. Al2O3, where SiO2 was slightly more than 50% of total oxides. Elementary molecular structure, elementary molecular structure is based on units. So, elementary molecule structure is based on units comprising silica tetrahedra, remember this, and aluminum octahedra. Silica tetrahedra, aluminum octahedra, cation Si plus 4, cation is fourfold and possesses tetrahedral coordination with oxygen. While cation Al plus 3 occurs in sixfold or octahedral coordination. Surprisingly, something let me repeat. Elementary molecular structure is based on units comprising silica tetrahedral, aluminum octahedral, cation is fourfold silica, Si plus 4 is fourfold, and possesses tetrahedral coordination with oxygen, while cation Al3 contains a sixfold or octahedral coordination. A layered structure is influenced by what? Influenced by presence of charge. Layered structure is influenced by presence of charge. So layered structure is influenced by presence of charge in tetrahedral and octahedral sheets, isomorph substitution in clay, isomorph substitution in clay. हम्म, ये यार क्या करूं मैं subject is like that. What I do, I'm not thinking. I'm just referring to both. If I think and speak, that's different. And layer structure is influenced by presence of charge, presence of charge in tetrahedral and octahedral shapes, isomorph substitution in clay mineral mainly produces charge mineral crystal without modifying its chemical structure. For example, For example, Al3 plus can replace Si plus 4 in tetrahedral coordination, and replacement of Ai3 is possible by Mg plus Fe2 plus and Fe2 in octals coordination. Uh, okay. Now, sheet present sheet present in Mount Morillite is sheet present in Mount Morillite are composed of 2 is to 1 structure. Sheets in crystalline crystal plane have a negative charge and hydroxide group linked to aluminum and magnesium. Electrostatic force is primarily the force of um, electronic electrostatic force is primary primarily force force of attractive. So now we go to so it says sheet present Mount Monolite are composed of 2:1 structure, sheets in crystal plane, sheets in crystal plane have a negative charge and hydroxide group linked to aluminum or magnesium. Electrostatic force is primarily force of attraction between sheets, however, it's fragile. Okay, now we go to this is page 4, 5. Now come on to in nanoplan. We'll discuss this later on. Let's go. We'll go to today to contracts also today. I'll take up this tomorrow because it's very complicated technical terms. I liked because I could not talk on FIDIC for many days. This is continuous, no issue. I'll go to FIDIC. For timing, this I remember this page is 5 of 17. We'll continue this. But now I'll go to this. So yeah, Alright, now I open page FIDIC. Now that's important. Let us start with that. Physics silver. FIDIC, are you there or gone? It's gone somewhere, I think. Thermal soil, electrical bitumen. Yeah, it's here, it's here. Say, lucky I cannot go to directly otherwise. Now we'll go with this FIDIC. Let's start. Last one. FIDIC is very important, soil is okay, fine, that's technical part, that's very important part. But FIDIC is also very important part in this. We should not take for granted FIDIC. This is also very important for engineers to understand. Let me put a full foot of light because I think my light is no use now. So, sorry. So my idea is FIDIC, and I I should say that let's go down. No, it's not that far away. It is program times for completion, commencement, there is a suspension. So not that much, I think. Labor and something we're talking of that day. Testing by contractors, plants, metals, workmanship, this all context person. I think labor laws we discussed, working hours we discussed. We all what we were discussing, I actually don't remember. Superintendents and context person will discuss disorderly conduct, field personnel, plants, metals, and workmanship. Let's discuss this. Plants, materials, and workmanship. Plants, materials, and workmanship. Let's say, and let's also say this is FIDIC. I'm talking FIDIC here now. About 1 hour we'll talk FIDIC. After a long time, just included. It's very important also. We cannot miss it. Otherwise, I know that this is different for engineers. This is not easy. They can be understood, but they cannot understand that. I know, but it doesn't matter. They have to understand. No way out. They have to understand this is their right. चल यार. So we did now soil engineering. You can say this is we have to do now. FIDIC here. FIDIC 2017. Red plus silver, and we have already talked of FIDIC 2017, and we talked of soil engineering. We already talked of soil engineering. So this is not FIDIC. Okay. So gentlemen, just to refresh mind, to come out of laziness of soil. Mont light clay soil means very much chemical terms are there. Many chemical terms in that. Force important indeed, very much important. But contract is also important. Contract is not having technical terms as many technical terms. Soil is having, but contact is having different terms, which unfortunately engineers miss. Contract, as we said long back, I discussed. Just like I said, project, do, think, and deliver. You say think and deliver. I said this my own definition. It's not other definition. Think and deliver. It includes everything. That's why particularly I'm using word think. Sometimes nowadays we are using so many words like Internet of Things, IoT. There are things they are using. Ultimately, it's very common word. In fact, you can say very common words are very important words sometimes, and we don't realize them. These are. Similarly, this is think that is very common word we don't realize. We say it's very. I don't think. People say if you raise questions or if you interview someone, say means if you don't have any concrete answer from someone, I am not going to give any concrete answer. Or you say, well, I think so. It should be like that. I think so, but I'm not sure this means is that. Right? They say, well, I think so. I think it should be. Like, no concrete answer. I think it should be. Why are you thinking? It should, I don't think this word is actually misused, abused. When you think, it should be concrete. That's what I say. There's no sequence of thinking and then next thinking and then next thinking and then next thinking. No. Think means think. Otherwise, this is not thinking. I think it should be done like this, and then again I say I should think this way. Like how we, what's the meaning of thinking? That is not thinking, That is something to assume, presume, or consider. Something is given to you for consideration. It's up to you to accept that consideration, not to accept that consideration. But not agreed consideration, that's not agreed consideration. Similarly, think is a powerful word because when you think something, it can't be wrong. First of all, you are thinking on your own. There may be many options while you're thinking. That's different. But once you say, "I think," this is my thinking. When you present your thinking, that is not an option. People say that's an option. I don't accept that. Contract is not a thinking. Contract is concrete. So what you say about contract, you think about contract is concrete. I particularly using this word in this title think. Thinking is only resort because when you think, you decide. You cannot defer it. If you defer it, means you are not thinking. Thinking has a procedure. You simply cannot say, I'm thinking, and you are doing nothing, you are not thinking. You assume you are not thinking, but I'm thinking. How much? On what basis you are thinking? Question is that. This is my basis. Okay, decide. I say, think leads to decision. When I say think tank, what is think tank? Think tank. What is that? A body of person think. But when an individual think, this is decision. Yes. When a body of person thinks, that can be decision by one. Yes, your thinking is your decision. Others guys think others decision. That decision is valid or not valid, that's not a point here. But that decision is decision, thinking is thinking. So contract is something beyond thinking even. Because it's agreed, thinking doesn't matter. It is agreed. When I say you say it's a contract, right? What does it mean? This means it's running or it has to run, but agreed between whom? Agreed between those parties who are signatories to this contract, and not simply those parties. There are some people independent of that who witness that contract. That is legal point. But even if there is no contract, then right, there exist contracts also. When two people say yes, we agree, that's a contract, verbal contract. We are talking about written contract. Yes, written contract, that's an agreement. Based on your proposition, based on your offer, they say you are awarded this contract. Based on what? Based on your offer. It's not plain because you agreed, you submitted your offer, that's why I say it's a contract. It's equivalent to contract. If you don't sign anything in future, post that award, post that acceptance letter of written, it's also contract. It's also contract because that is not independent, that is dependent on your offer, on bidder's offer. So we have to consider contracts also in different light. It's not simply underlining main points, simply understanding what whether contract exists or it doesn't exist. Contract is between two parties, that's true. Two parties who agree for something. One party says, I do this work for you, and other party commits that I will pay you this much. Now, guys, friends, I know that civil engineers, particularly young and of course middle-aged people, they are not very much interested in understanding contracts. I have know this. It's not because they don't understand, because contract is a voluminous document and little complex it is. Language issues there, and they have no patience to read these documents. When contract is there in details, and particularly EPC it is, and lump sum price it is, it's very powerful document. We have done that book. We have gone through that. Red book is also powerful. Red book is actually practical contract, and this is different contract. In red book, we know that contractor is real contractor. You know why? He has to just construct. He has to follow his comply with details scheme. Details means design. Contractor is not going to do design itself. Well, of course, exceptions are there. Contractor say, I'll construct this for you according to your drawing specifications or requirements and codes. Even codes we won't follow because it comes under construction. Why should I worry about codes? So red book says you work and go. Now red book says do it and go. Do it, take payment and go. Simply. Do not think about design. Think about construction and quality and times. Red book says give quality, save time, be efficient, follow design, construction responsibility is yours, design responsibility mine. You are responsible for correct construction. You have to prove this bearing capacity must be on site, and if not, you have to achieve it. That is right. You may write this is we expect this bearing capacity, or this was expected by test, or this was found by test, and it should be there. This can be a point there which people don't notice otherwise. So their responsibility lies with conditions in that contract, in construction contract. Here we are talking of EPC, that is silver, engineers procurement, construction contract. There should have been. Red Book said we want expert staff in construction, your staff, expert people in construction. We want expert people in coordination. We want expert people in execution, and we want to check everything. Even sometimes facilities to come check for checking, or their engineers is for checking. But in this case of construction, they because this is their drawing and their when we say EPC silver work, it is something extraordinary. Like no, it's not extraordinary, but I say something like extraordinary for engineers. I have seen that our budding engineers, in some others also. Difficulty arises in EPC because every bidder is not well qualified to become EPC. EPC and trade or construction are different words. I was on a contract that was construction contract EPC fixed in Doha, Qatar, and consultants were very strong. I was from contracting end, very good construction, intelligent construction, contractor. Designs were also from organization and project was government project, highway project, Qatar petroleum project. Starting was very difficult. You have to follow their procedures. Your procedures are not enough. You have to follow their formats. You have to follow everything what they say. Okay, gradually we adopted that. Meeting was conducted every 7 days, every 7 days, not month. We started submitting materials, drawing, excavation, everything. Everything started. It was rock, and there was requirement in the specification. You should get this much bearing capacity. You should get this much bearing capacity before foundation is raised. I mean, to start it. You can't contravene. I don't know. Somebody noticed as time of bidding what is right. Nobody thinks that. Nobody thinks that. Because when they, particularly in construction contracts, when people have overconfidence, they don't even go to site before bidding. They do. Nobody went to site even to see labels. And this okay, we have various experience in construction. Just take BOQ, find rates and fill up. And not even bother about construction quantities. Not even bother about that, which is a must. My suggestion to all those who are in lump sum fixed price contracts, either on both ends, engineers and contractors, and for me it's no difference what I say. It's very important point I'm discussing here, that that both quantifiers on both ends, engineers and contractors side, at time of at time of bid or preparation for bid. In fact, engineers and quantifier is very careless, non-serious, because they are not going to suffer. They shall not suffer. If quantities are wrong, whatever percent is, no one is going to question them. But they don't understand purpose of bid preparation is also very important, because yes, there is a budget, we know there's a gross budget, provisionary budget, but there's another basis also which they consider based on quantification. Nobody would say anything to you. You know your quantities are wrong by 50%, say. Or if you forget some item, or you put more items, nobody is going to say anything to you, because your BOQ prepared by engineer is not legally admissible in such cases. This is not a valid document, you can say. Yes, this is a part of contract document, but not that very, very low profile. Actually, it is equal to zero contract document, you may say. This is a point where people are trapped. What happens actually, bad habit is bad habit, right? What is bad habit? Carelessness. First of all, those staff people, those engineers, professionals who are involved with preparation of bid documents, or or preparation of technical submissions. Technical preparation of submissions is contractor or bidder. They have to prepare for technical submissions, and those who prepare bid documents, they have to prepare documents for bid. Both have different approach, different person who is on the engineer hand, that person thinks I have to finish these documents. There's a milestone date, and we have to dispose of these tenders so that get we get back quotation. I mean to say bids, tender. It takes time for quantification. I understand, and particularly when new work is involved, whole building is involved, many buildings are involved, and infrastructure also involved. It's not easy to quantify. It takes time, and it takes your concentration. It requires your concentration, and if you don't concentrate, you miss. What happens in a haphazard area? You have four projects you handle, three projects you handle. Nobody handles projects, single projects to concentrate upon. So today you handle this, next you handle that. Maybe after 1 week you handle that. If you did not finish that, you start that, or you come at night and sit and do it. You take home the sensitive. So in such a complex, demanding situation, concentration does not stay. It remains as if I do everything today, tomorrow it has to go, but it doesn't happen. Many times it happens, we go to sites, See yours there. Yes. When document is prepared by engineers person, there are many errors, because engineers persons are not going to be responsible for anything, and it doesn't affect them financially because first of all they are young and they have no experience on contracting. They just formally, and they know that bidder shall check it thoroughly. This is they know or they presume, means they take it. I am not going to suffer. Let them suffer. Let them work because they are going to make their own BOQ. Why should I be okay? This is okay, fine. Only for guidance they will write. This BOQ is only for guidance. They will write somewhere in specifications. They would write and shall bidder read? Bidder won't read because everybody is confident. Clearly, you'll find if you go through documents the BOQ provide is only for guidance, but nothing to do with contract documents. That point can read only if you read documents. And if you don't read documents, how shall you get that point? You won't get that point. So you may miss. So what happens in some cases, people just use same BOQ and price. It's still the same price. Drawings there, everything is there, all discipline drawings are there, same drawings are there, mechanical parts there. What you want to do? What happens on contractor end, on bidder end? I'm not calling Canada bidder end. Bidder end is also not very serious, practically speaking. Nobody is serious, in fact. Bidder is also not serious. I don't know reason for that, but bidder is not serious. Some are serious, some are not. Because what happens, you buy tender, okay, keep it, we'll see. Then they constitute some team to work, and it takes only maybe only 7 days are left, 10 days are left, 15 days are left to close tender. In what happens in that case? Because you are not doing everything yourself, you have to obtain prices or quotations from various vendors who are going to do services jobs for you or some other specialist jobs for you, and you are just you know you're inclined for civil specifications. For example, concrete, block work, brickwork, and all that. Work is coming. All the services guys say actually very good. So, I mean, this is only. So when you have only that responsibility, that you have to invite quotation, you have to receive quotation, you have to send documents. Your time is very much occupied. Then you ask someone, you prepare for quantities, you prepare for this, you prefer timberline entries, you prefer that entry, this entry. Of course, you have a team, or you alone work. You don't have team. Question is, rates you have, you can find rates. Item rates not a big issue in contracting companies. They have their, yes, excavation can be different. Of course, there are possibilities, but if it's too much, Too much or not too much, we excavate on sites. Even if it is not quantified, you have to excavate on site depending upon convenience of movement on site. In excavation, convenience is more important rather than sticking to quantity of excavation, even if it is wrong. That's what. So, my dear, question is only quantity dominates price of any construction project, whatever that's called. Red book means construction project. If we don't have real quantities, they are asked to follow this television, and that television say and get news. You follow this, and get news. It happens. So we use those BOQs which are given by consultant when we don't have time. We'll check later on. This is not fun. You check later on. Quantity, if miscalculated, blunder is done, or drawings are not well understood, and so my statement here is if you make mistakes in quantities, your tender is gone. We once met one person builder in Abu Dhabi. We had to tender for a commercial building, and there were many commercial buildings of similar or typical designs in that road. It was lump sum contract and fixed price. We we opt out. We also made same mistake. Our manager say, "This is a small building. Yes, we have done that building. We used to pro rata. You find a total cover area and this and that and that. It- Bad habit. Well, we did that. No problem. Yeah, of course, I used to cover many points in my mind, and I used to cover areas and all that. Like we had a price. Uh, our price was not lowest when this tender opened. Lowest price was for someone else. Well, no problem. It's gone. So that person, people started telling, "Oh, you are lucky. Congratulations." That person is arguing something. What's the same? How did you calculate this price? Somebody asked that guy, that tenderer, how did you calculate the price? Because they felt something is wrong. Some people ask him, because our price is coming different. How could you get this price? Oh, this is same building and other buildings there. We come, that building is there because so. Who told you that? Question mark. Who told you that? Why you also why you talking of? It's same. No, it's not same. Design is same. Stories are not same. What? Yes. In this building which you have offered for construction, there is a basement. Did you take that into consideration? There's no basement, he said. There is a basement. That person did not know that this project had a basement because he copied from other. He saw same drawing, same title, just changed title. Then you start crying. Why done? He did not see drawing. He did not see specification. He did not see anything. the same price as the previous. There are people like that. This is small scale construction group I'm talking. Same thing people do in big also. That's why I'm telling you, project of Doha that I was talking about, where we have to ensure bearing capacity of that soil strata. In that, consultant indirectly told us, your price is wrong. I was not there in that pricing. I was not in that country that time. Says there is your price is this. It's about 1.5 million less than it should be. You are going to lose this project, but you have taken now. You have to follow everything because according to their calculations, our price was 1.5, say 1.2 to 1.5 million lower because our people did not calculate. This happens. There was another tender done by our company in that case. Means tender section, I should say, not myself. There was a tendering guy. He finalized one bid. I mean for submission, price submission. And when it's opened, there's a difference. There's a gap difference. Big difference. 1.5 million real difference. Owner was shocked. How can it be so much difference? He asked tender guy who was involved in tendering, check it once. What you have missed in that? And missing item was discovered. Kilometers of cable was missed. Armored cable. That was an item which nobody noticed. You know, this happens in such contracts. In one case in Doha, this was also Doha, in road contract, road tender. I was there in that company inside then. The road section was there front. Some error. In those days, there were no major computers, very small computers were there, DOS related computers, dot matrix. This was about more than 100 million project, 100 reals project, 100 million reals. Our company, our company quoted, I mean to say not quoted, bid. And when it opened, there was a difference of 18 million reals, Qatari reals. They were happy that they were lost, but when they say how it is, see, there can be difference of 2%, there can be difference of 1%, 3%, maximum 4%, 5%. This is a 20% difference. There's something is wrong somewhere. All are fools, only you are intelligent. You see, problem is quantity is calculated by quantifiers. Drawing is there, details are there. If you ask four quantity engineers, sit down and work each on these, all will give you same result if they concentrate. You cannot change mathematical calculations. You will get same. This happens. Yes, there can be little error, 0.5% error. Maybe some measurement somebody doesn't take correctly, or there can be little variation, but not 20% or 15%. So quantity, dominates. Quantity dominates your material price, item price. Yes, there can be difference in something else. Overheads, you can say there can be difference. Quantities cannot be different. This means there can be variation of 1%, 2%, 3%. Maybe you are paying lesser wages to your workers or to your staff, or you may be having good suppliers who can give you credit something. There can be little difference. or your subcontractors are good for you, they charge less to you. But it can't be that much. That's why I'm saying if you are in this field, in this profession of tendering or bidding, you want to make a career in that. This is very important, much more significant than designs. In that sense, responsibility is yours. Design is not going to change anything. It is to be done. But if you mistake somewhere, because design shall come to you and you will find out quantities. Because design is seen all the time, quantities are not seen. You are doing taking off from something, you're writing on Excel or somewhere else. You forget some item or you write double item. Many BOQs are there depending on project, and you're not doing that project only. Sometime you do today, tomorrow I will not do this, tomorrow I'll do something else happens. Oh, this extension of some mission, so let us put this in cold storage for 2 weeks. We'll take after 2 weeks. This happens because people keep on applying for extension of some mission date extension something. So oh, oh, it's so too much time, 2 months time, leave it now. We'll do later on. You do this. So you it's like that. When you get up after 15 days, or maybe you go on vacation, somebody else comes. This happens because they take it. It will not okay. You check it what he has done. They'll simply okay. You have a review for what guide and you keep them forward. What happens? Either you take double quantities in some cases, or you forget something, and your own work you cannot check. The problem is that checking quantities is very difficult job. Everybody has different style of working. There are thousands of entries, thousands of entries, maybe more. For small items, nobody bothers. And you are under force now. Do it now. You have to finish tender. Do it now. You have to sit at night, take this at home, do whatever. Your mind is hot then, nervous. So what happens? Review doesn't happen peacefully. Even if you are serious, that error you will not find until you sit peacefully and concentrate. So what happens? That errors, which is once single one, goes on accumulating to whatever times. That kills your tender, that kills you, and you cannot run away. Once you have submitted tender, once you have submitted your tender, you have submitted tender bond as well. If you run away, your tender bond is gone and your reputation is gone. They won't give you second time chance for tender. And if you don't submit, that's also another problem. You are expected to submit. See, there are so many points in this line, so many barricades in this profession. It's not simply we are calculating. Calculation is important, but many others. Technical submissions. Technical submission includes quantification, includes resources, all resources, includes their schedule, includes your procedures or methodologies of project completion. They would like to see are you in a capacity, understand and do it. If you say you do not know everything, then you are not competent. That's why I'm trying to stress on quantities. Even if it is EPC, same applies. Only difference is here design is yours. That's the difference. There, in that design is not yours. But when design is not yours, then it's more difficult. You have to understand design first. Here you are doing quantification yourself. There you are getting some feedback from there that can confuse you. That can also confuse you. Quantification is very difficult job in buildings, particular buildings. I'm telling you. I'm not telling in road work or in irrigation work or in water supply works or where mechanical engineers are different and there different type of calculations. Not like this. Everything is clear here. Here, so much you have to imagine. Who sees a steel ring? I mean to say steel rod by rod, bar by bar. Who sees that? No one sees that. Just try let us assume 100 kilogram per cubic meter or 120 kilo, depending on 200 kilogram. You just you cannot go and make complete you can say bar bending schedule for project and say that this is this much. It doesn't happen. It never happens. It doesn't happen that way, which you think it is. That's where you fall. Then you have to calculate everything, and also even if item is not there, you have to do that. Maybe they say just this is RCC quantity, so many cubic meter. You consider that way, and the price of that item. This whole quantity element wise is this. Each element prices. You don't consider your shuttering or your steel fixing separately. They want to see it one item, or otherwise they say no, take all items separately. Form work is so many meters, concrete so many cubic meters, steel fixing so many tons, or so many like that they give. They give this way or they give that way. You have to calculate both. Even if item is unit one, means everything should be packed in that. You also require to calculate. This I am telling you because of my experience. That people, I we used to know it also. We used to know it also. Matters. If a generation think that will get every facility sitting in, and no problem for that. And maybe in some cases, many female engineers work in offices, so it can all cause infection. Well, my 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 suggestion is for everyone: be mature. One one cubic meter loss in concrete means something. Remember, 1 cubic meter of loss in concrete is something. Therefore, don't rush and do point by point. Don't be fast. Quantity should be accurate because you may go after tender, somebody else would be there, or on site, somebody else will be there. Based on your quantity, there will be a chart graph, BOQs there, and that BOQ goes to being considering as a list of items or list of materials goes to cost control. You think they separately calculate? No. Same allotment of cost is given according to codes. This item, this item is code, and this is your budget. And you find that you miss some items or undervalued some items. Your budget is undervalued. Okay. This happen, this happen every day. Gentlemen, contract is contract. Because we are talking EPC, still there is time to continue. EPC is where you are designers. Yes, field is there, but trying design philosophy may be there. You have to comply with that because of bylaws and so many other issues. There could be. You have to design your structure. You have to design the structure, and if you are also having MEP contract with you in same package, you have to design mechanical engineering also. You have to design electrical engineering also, and plumbing as well, and landscape as well. All come into your preview if you have complete package of EPC, and that is where your smart sending or smart machine. EPC means engineering, procurement, construction. Engineering is a big part in that, and until engineering is done or drawings are not produced, you contact in quantity section. And until you have good designers who can understand contract, because contract is also there. So it's your design, contract is there. That contract, how does it impact on you if you don't understand that? There should be some contract expert. If you don't have anybody, then some of you can be to manage that. Later on, when you find that everything is ready, drawings which you produced meet requirements, which you have to see through specifications. Sometimes what happens, drawings people, they do not care for specifications, and moreover, they are not used to that in design philosophy. They are not used to what is given in what's required. So you have to also ensure whatever design is done is according to contract requirement, because you have not to deal with one discipline, you have to deal with all disciplines. That's where problem lies. Sometimes it seems the project very easy or it's not time, it doesn't take much time, but when you start doing that, at that time you're trapped because of lack of information or because of incomplete information, you are trapped. That point is very important, how to come out of that trap. That trap is very tedious, very difficult, and one must come out of that. Nobody would help you, you have to help self. Yes, you can say that I have done this, I have done that, and all that. Hello, hello. Yeah, I'm open for yeah. You have done this, you have done that, and we have to see this, we have to see that, we have to understand design, then we have come out with contract, complete quantities. This design goes to HVAC engineer, it goes to electrical engineers, it goes to other engineers. They also work on it. Design comes in different stages. It will come first of all information, preliminary design, or it may come to you only as a, you know, only as for you have to. I meant to say assume so many things which may not be working capacity or working able design. So you may ask for more details. So it will take time, or they may say you assume this time, we'll give you later on. Both are very difficult stages. Design takes time, and in contracting, I'm not sure that designs will give you complete details. They will give you just preliminary details, and you follow them. In that case, your smartness work. If you have experience of what it should be, what it should not be, you can be fine. Otherwise, you can't be. It's very difficult. They may they may work out anything temporarily to be revised later because yeah, they're not going to do that on site, and problem lies in. But without that, it's not possible. Particularly happens in mechanical foundations, machine foundations. It happens a lot. May not be for buildings because buildings are generally. I'm talking of plants, projects, where there are combinations of all kinds of structures. They're kind of ordinary structures, and there's, you can say, storing structures, warehouse structures, electrical structures, blast resistant structures, blast resilience structures, free blast structures, and maybe underground services structures. There can be different kind of buildings and different kinds of, you can say, structural steel buildings and RCC buildings, or some other types of buildings on such projects which requires your attention. That's very important one. And then in addition to those, there are very electronics items, electrical items, electrical, mechanical related items, and there are pipe racks, and you make bridges, internal bridges, and then there's internal road system, and so much underground utilities, and many other types of structure, open some reservoirs or some lagoons or some outfalls. There can be whatever it is. Everything is required because you have to keep water isolated, so you can say outfall is required, or you maybe use seawater storage is required, the seawater sent into all areas is required, and after that is come to outfall, and it goes from there to the treatment area. All that comes in such area. If you can understand that. Assessment of quantities are generally taken by in such cases because you don't have detailed drawings, detailed works. So there is no way that you may take definite counted quantities of whatever material. It may be structural steel, or it may be RCC, or it may be whatever. Then you have to apply assessment, which is risky one, of course. Nobody can say no, but because you are experienced company, you might have done same work before, you are repeating that. In that case it helps, but if you are not repeating company, you are trapped then. Maybe you are not fully PC, you are subcontractor. In that case it's okay, it will work. You lost details from your main one, but otherwise it's very difficult to handle. I have seen people suffering from that. They cannot even understand complete design till end of projects. It happens, particularly where machines are involved. I'm again stressing, machine doesn't mean small machines. Machines mean bigger machines, equipment machines, vibrating machines, vessels, big generators, big compressors, those types of which require maybe very heavy foundations, massive blocks which require. So those after all cost, massive or no massive, is cost, very much cost. And to means in such situation, I can say that EPC is very difficult. But there is no way out. You have to do that. Because if you cannot do then you cannot expect as employer to a company that giving you this project do. If they could do at least by themselves. They're not given us chance to. There is opportunity for this. And because we think that we are going to have opportunity first time we are into this field, and this company will value us, they are poor people like us, and they, okay, this is. So point is that it's everything is not smooth as we say. That's what I was saying in APC, which is your point. I just tried to read that, but I just started thinking something else. In this, we have talked here up to staff and personal from both ends. Staff and personal that is on site, you know, they call in EPC accordingly. For me, well, I don't believe that. For me, employer's representative is considered responsible in EPC, while engineer is considered responsible because it's the contractor follows a FIDIC. But I don't believe this. I don't accept this personally because you can't say employer's representative is responsible for this. Employer representative is representative. Representative is representable. We are not dealing with representative. We may deal temporarily, but finally competence must be there. And in Red Book, for example, engineers there is a independent person, independent authority to decide. We need that. So they may say employer's representative in EPC is responsible for that. I don't accept this. How can employer representative be responsible for everything? When you say representation of employer means it's attached to the employer. And when I say engineer, engineer is not attached to employer. So either you section that designation into engineer, employer's agent, or general attorney, or whatever else that's there. There should be a portion in that position which is engineer or equal. There must be engineer rank in that because after work is what? Only difference here is it is engineering additionally. Procurement was there also in fact we have to procure material. We have to approve that approval of materials, development drawings, everything. Only difference is in this we have design element to do ourselves. Design element, of course, it impacts budget, but design cost is not that high, 10% maximum. So for 10% allocation, you are changing designation. To make it more difficult, we want at least that person to be nominated engineer also. Or there should be an engineer in that place. What's wrong with engineers there? What's nothing wrong? If you can call employer representative, you can call also engineer. What's wrong with that? Engineer is not representing employer. Engineer represents project. They represent projects. But employer representative does not represent project. That represent employer. That's my internal argument. I cannot check on FIDIC, but I may write to them sometime when I think so. This is my case. I'm just clarifying what I think because ultimate responsibilities goes to engineer. And when say employer representative means they may assume, oh, this is mechanical project, 70% cost is going to be a mechanical work. So we should have mechanical person or we should have that person. But they don't understand. Mechanical cost is high because of equipment, not because of work. Equipment are not done on site, equipment are procured. That's the difference here. We must know our limits. We must know everything. That's what's required. Easy to say anything, but fact lies somewhere else. That's what I said that here personal are okay, Employer has, I'm to say, engineer has every right, like employer is right. Employer has right to accept or not to accept any proposal of engineering staff, of contractors, or of, you can say, of employer. Every everybody has right for his company and to accept or not to accept CVs. It's also right of everybody. But question is not of that only. Question is performance. Performance that is important. Who can decide performance? Performance means every performance. It's not simply site performance. EPC is particularly more different than that. At least in that we have documents, we have design, we have something received from engineer or employer, and we move on that. There is no nothing unclear. But what is now? This COVID has changed everything. If if I have to arrange something with contract, I have to decide and arrange. And that decision based upon approvals, of course. EPC is very big project, or even if it's for small, it's also same. To get progress on any construction projects is not that easy. Even if you say we have machines, we have this, we have that, that is supporting system. But procedure is expensive. If you say project is say for 1.5 year, let us say 1.5 year. Oh, 18 months project and it's very small. Yes, it looks small, but is it cost of that? 2 months end of project is no use. You have to do testing and commissioning. That is out. 2 months out of 18 months. 1 month is mobilization, which may take 2 months minimum. So 2 months there and 1 or 2 months here are out. Then you think submissions of materials and drawings go so smoothly? Never ever. Do you think you get employees or staff ready on time? Never ever. You think you get your drawings done so fast? Never ever. You think you can procure material, whatever you have to use on project at one go? Never ever. Time is same, procedure is same, delivery is same, custom is same, duties are same, only quantity is less. Only quantity. So project is big, it's not small. You may buy 1 square meter of tile from other country, or you may buy 1,000 square meter of tile. It's shipment, no difference. You may buy one package unit or chiller from USA or from some other country, France, or you buy four. It is one and same. It takes same time. Where is difference? Where is concession? Nowhere. We have to understand this point. This point is very important, not a joke. We cannot consider it a joke. It is very, very important. Contracts cannot be taken as if it is nothing, because if contracts are not done, project cannot be done. Complete supply chain collapses. Chain from budget, design, further. And this end where delivery is to be made. If there is no fixed support, you can say in bending moment and language. If this factor is not very fixed, explained, There is no support here, it collapses. And because there is no support, and whole becomes cantilever. And if there is support, it's also fine. You can handle all collapses. Do you understand? I would say I'm not supporting contracting. You do yourself. Don't do contract. That's not possible. No consultant, no designer would accept this. No employer would accept this because it is big headache. You think it is easy? No. To demand quality is easy, but to deliver quality is difficult. To extract quality is difficult. I can write you should give this and this and this and quality, this our system. Correct. Help. You can do that only. Okay, you go to site and do it. You are writing this. You are bigger engineers, consultant. Okay, you take charge of site and do it. Your grandmother will come to you in your memory. You understand? Contracting is a war. It's a struggle. Contracting is not that comfortable as people assume. Oh, there's big money in this. Okay, do it. I have seen companies collapsing. I have seen running away because they sign too much to take project, but they run away after signing. So what is fun in that? It's a big question mark here. Don't be happy that you think you got a project. Getting project is not difficult. Project is difficult. When term comes contract, it's binding. It's binding, not assumption. Binding this way and that way and from here to here. All if you don't do it, you're killed. And if you do it, you're killed. If you can't control it, it's competitive work. And this competition not in pricing alone. This competition is quality. This competition is safety. This competition is planning. This competition is formal technical work. This competition is controlling site work, controlling resources, avoiding wastage of resources, doing everything that is required to be done. Contact is not a game of cricket and football. We lost this time, no problem. Next time we do it. Next time does not come, never comes. This is concrete world. This is construction world. If you are not serious, if you are not routine, if you are not regular, if you are not committed, if you are not determined, if you are not well-willed, I mean to say you have no will, you cannot complete a project. If you don't have good workers with you, if you don't have good staff with you, if you don't have good subcontracts with you, if you don't have all this stuff with you, you cannot complete a project. This is well controlled statement, determined and calculated statement I am making. It's not that easy your thinking, not that easy. It's completely different if you think you're right. Contracting is not that easy as we think or you think. It's by chance you are lucky if you get good rates. By chance you are lucky. Or you are a subcontractor. You take work from some big contractor and get good rates because in those big projects and those big people may not mind giving a good rates so that just to save headache. And you bring cheap people and get it done. Sometimes it used to happen. And you have a good margin, say 20% margin. Even if you make 5% loss in that 20%, still you have 15% margin. Or if you have 15% margin, you make loss of 4%, even then you can say have 10% margin. So like that, you may be lucky that you at least survive. Otherwise, it's very difficult. Nowadays, time has changed, COVID period, economy is down, Everybody shall like to have work without thinking when economy restarts, and that shall cause another problem for everyone. Problem is problem. Try to understand. Problem is problem. It cannot go like this. It's easy. Problem is problem. We cannot stay with problem. Problem must be resolved. That is life. If you cannot resolve, you lose everything. That's what I say. Therefore, my dear friends, I want to talk more on this, but it's time already more than 5 hours. I will continue with this. Today, I just try to express my mind. I'll try to move because prevention, protection is very important. Contracting is not that easy. It's a profession. Don't think it's takedari. No, it's not takedari. It's a profession. More important, it's a part of engineering. It's not otherwise. Don't consider it an isolation. It is construction engineering. It is contracts engineering. It is contracts engineering, which requires your maturity, which requires your breadth of law, which requires your experience, which requires plus and minus everything, which requires technical knowledge, contractual knowledge, design knowledge, working knowledge, handling knowledge, fighting knowledge, and many other kind of characters in it. And if you have that, jump into this line. And if you don't waste your time, then don't go to contracting, go to other field where you feel comfortable to sit in AC rooms and work, you can go there. There is no harm in that. Otherwise, you make mistakes, you will make mistakes. In contracting, here nobody will check your mistake. You mistake means when mistake is caught, that time they'll catch you. Because they trust you, you are engineer, you can't make mistakes. They believe you because your mistake may be known after 1 year or 2 years. By that time, you may not be there, so company would suffer and they will abuse you. This person was there, he did that. Or you are there, then you'll definitely get a question to answer because engineer position is that, engineer job is that. I'm not talking about contract engineer. I'm talking ordinary educated person who is employed in the position as engineer is required to be employed. That's not easy. That's difficult like that. So with this, I would like to thank you for today's little long talk. I wanted to make it a little longer because I wanted to include some time for this contracting as well, and that technical soil mechanics. That's I'm also going to take time, and it's a very boring subject, and of course we have to understand everything. So I would say we continue like this. I hope, and with that statement, I would say thank you very much, everyone. I close this now. I hope you may like to continue or you may use this talk for your benefit. It's not entertainment anymore. It's very serious discussion. I am sharing with you. I'm not getting any feedback. That's my bad time. Or you're not writing anything to me. Well, either you're not serious, you're not attending, you're not viewing this, or I think that maybe you know nothing about that. Then, if you know nothing about, then yes, it's a chance for you to learn. It's positive and for you. Or if you know, then you better write to me. That's this right or wrong, so that I can check myself. With this, I say thank you very much. I close this YouTube first, and then I'll close other one.